Welcome everyone. My name is, for those of you who don't know me, my name is Robert Nirenberg. I'm one of the co-PIs here at the BEST Center along with Ted. We'll do introductions and everything here in a few minutes. But overview for this workshop. As you know, we are here for 5 days. Our first 3 days will be here at MATC, where we will be focused on activities. Okay? Notice I did not say we're going to be focused on lecture. You are going to have to put up with some, but not for the most part. We at the BEST Center really like to model what we teach. And one of the things that we've learned over the years is our students, your students, how do they learn? With their hands. They learn by doing. They're kinesthetic learners. So, I don't know about you guys, I am mostly a kinesthetic learner. I learn it by doing. So, practice what you preach, right? So, we'll be doing a lot of hands-on activities over the next 3 days. Day 2 is a little more lecture, but we still have lab activity associated with it. Okay? Make sense? All right. So, day 1 is BAS Basics. And I know a lot of you have been here before, been through the BAS Basics, but who feels comfortable with BAS Basics? Put your hand down, Brad. Yeah, Rob in the back. Okay? So, that tells me that everybody is here who should be here. We do have one person joining us starting tomorrow, I believe, Pierre, from South California, who will be joining. Day 2, we start networking. Who in here is comfortable with networking? A couple people. That's an improvement. Normally we have crickets at that one, so we're stepping up, which is fantastic. Day 3, troubleshooting. Troubleshooting BAS systems. Okay? Who is comfortable with the general topic of troubleshooting? HVAC, electrical, IT, I don't care what area. Who's comfortable? Get your hands high. I wear glasses, so I need to see hands high. So, good number of folks. Okay? Who's comfortable with troubleshooting BAS? Little bit? Fantastic. That's good. That's a fact. That's an absolute fact. You never stop troubleshooting BAS from the minute you start installing it to the point where you're operating it. It's all troubleshooting. Okay? So a lot of the principles will apply. So think about that as we're going through the days. Okay? Day 4, we're going to go take a tour of the, what building is it, Ted? Northwestern Mutual. Thank you. Which is downtown, about a half mile from the hotel. Okay? Then we will head back to the hotel, and you will get to, or we will start working on our lesson plans, which are part of your report out on Friday. Okay? Friday, last day, we do our report outs. We have a good time. And then we all safely travel home, right? That's the layout of the week. Peter, did I miss anything?
No, you got it.
Fantastic. As well as our general topics, we will be talking about why we teach it, where we teach it, or when we teach it, maybe, would be a better way to say it. So where in your program does it fit? Why are we talking about basics? I hammer on basics because if you don't have a foundation, how do you build from there? Fair enough? All right. Let's do some introductions. Can you slide us forward a couple slides, Ted?
More?
Back one. So, as you all know, we are the BEST Center. We'll do some quick introductions. Peter?
Welcome, everyone. My voice is shot today, so when it recovers, I'll do an overview of the BEST Center for you. But we're really glad to see everyone here. It's great to see you, and we hope you have a good time.
Larry?
Good morning, everyone. I think I met you all during breakfast, which was, of course, noticeable with some coffee. So I'm thankful that you did not decide to kill me right then and there. Okay. So anyhow, welcome. This is our final in-person workshop. All right, so you are the last cohort going out the door. Make us proud.
Thank you, Larry. Ted?
I'm Ted Walensky. I'm an instructor in BES here at MATC, Milwaukee Area Technical College. So I'm your host. If you need anything for the area, whatever, just ask me and I might have an answer. I'm one of the co-PIs for Best Center. I've been involved with Best Center since 2013. So just ask away. If you want to see things here on campus while we're here, just let me know and I'll see if we can get you in there. Laura is going to get us into the boiler room on Wednesday. It's kind of like a long lunch we're going to do. So you'll be able to see that part. We're going to go across the hall and at some point Protective Services will let us in that room at the very end of it and we'll look in we have a boiler ripped apart so you can see the guts of a high pressure steam boiler. So that's kind of a background of what we're going to do and plus who I am. Welcome.
Ted, is this your main lab here, or?
Yeah, so this is the main BAS lab. We originally had that room and this room. That room has our lighting controls that we play with, one class. All the rest of the time we're in here. They want that room for sheet metal, so this is going to be the lab for BAS. And we just, in the process of, we upgraded to the new Metasys system, and it's going to go on all these control, or these air handling units back here. Matter of fact, they were on there before I took them all off last week, because we're going to the contemporary control setup on this one. So yeah, it's the main lab. We do get out in the building quite a bit, look at the equipment in the building like we're going to do here, because we try to, as much as possible, follow the campus as a living lab. And Laura and I will talk more about that on Wednesday.
So we're going to move on to introductions, and we're going to start with our two co-presenters for Tuesday and Thursday. So, keep it brief. We all are proud of our institutions, so we do want to hear a little bit, but we are, trying to get a lot in today. So let's keep it a little bit short. We will get a chance to know each other better, especially our new folks. Thank you for joining us. But yeah.
And just one thing more, we will have most likely an opportunity to see that particular atrium on Thursday at Northwestern Mutual. And I failed to stop and look at some other things, but we'll go back in a little bit. We'll let the introductions go.
There we go. Brad, you want to start us off?
Morning, I'm Brad Friel, Sacramento City College. I am a professor in the HVAC program there. I teach in our program is 2 years. I teach at least one class at each of the 4 semesters. My specialty is diagnostics and controls. What do I hope to get out of this experience? I've never been able to answer that question until after I leave here. But I always take something away.
Thank you, Brad. Rafat.
Good morning, everyone. My name is Rafat Sharif. I'm with the MATC here with this college. I've been here for 25 years, teaching networking and security. I hope that I can give on Tuesday enough of my knowledge to you guys. If you have any questions, please ask at that time. And see you Tuesday.
Fantastic. Rafat is our lead presenter on Tuesday. Brad is our lead presenter on Wednesday. So I've had a chance to preview their presentations. I think there's a lot there to learn. So that'll be a lot of fun. We're going to go ahead and continue down the back row. Kelvin?
Hey, good morning. My name is Kelvin Snell. I'm from the Southern Regional Technical College now, formerly Georgia Piedmont. Last year when I came out, I affiliated with one of our other state colleges. My role here is lead HVAC in charge of developing programs. We're in the process now of trying to start a BS program in South Georgia now. And again, what I hope to get out of this experience is always just the learning, something new, refreshers, so it's good for that. Thank you.
Thank you, Kelvin. Laura?
I'm gonna pass this one. Hi. Hi, I'm Laura Tenpenny. I'm the energy manager here at MATC. I'm not on the academic side, so I'm a little bit interested to see how that works for everybody and how you incorporate this into your classes. What I'm hoping to get out of this experience, I am really looking for some actual training on how to understand the networking and the connections of BAS. I've kind of been thrown into it and on the working side, so ready to understand the basics, I guess.
I'm Mike Newtown. I'm from SUNY Canton up in upstate New York. I'm a recovering engineer. I teach a lot of HVAC stuff. It's what I got myself into years ago, but they made me dean, and I like to keep my hands in this. And Jay Simmons has been taking over for me, and I'm always into practicing the skills that I've known and get better at it. So that's what I hope to get out of it.
I'm Jay Simmons from SUNY Canton also. I teach HVAC, mostly air conditioning, and I'm working into the BAS side of things. We're developing new courses and trying to develop that side of our program. And I hope to get out of this, obviously more into the BAS and incorporate it more into our program.
Good morning. Steve Gooch, Chippewa Valley Tech College here, Eau Claire, Wisconsin. I've been there for 25 years, actually, teaching HVAC. Last probably 6-7 years I've been doing the BAS stuff. And every year I look at the BAS class that we have, the 2 different classes, and trying to always find other small activities. And so far, the last 4 or 5 Best Center ones, I've been able to pull out small activities that we've done and actually bring them into class. And that's made it a lot more beneficial for the students and bringing everything down to a level that they understand.
Thank you, Steve. Jose?
Good morning. My name is Jose Luis Jasso, and I'm from South Texas College.
Speak up.
I'm from South Texas College, and I'm also one of the instructors at the college. And I've been teaching the class, BAS class, for about 5 years. Well, one of the reasons I'm here, I want to learn more, and I want to kind of experience or find more ways to get those students engaged, more hands-on. So this is probably what I want to take from here. Okay, thank you.
Good morning, everybody. My name is Guadalupe Sanchez. I'm an HVAC instructor at South Texas College in South Texas. Been teaching for 15 years. I'm a licensed contractor also in the state of Texas. A small business. I'm hoping to take over his BAS, and build up the network there and build up the class. So right now I'm in superheat mode. I'm going to absorb all the information that I can, and we'll go from there. Right.
I like
Thank
that.
you.
That's fantastic.
Hello, everyone. My name is Arnoldo Perez, Arnold, as everyone calls me. I'm from St. Philip's College in San Antonio, Texas. I somewhat retired from teaching HVAC about in 2022. I'm now considered semi-retired. I went back to teaching and helping the college build on the commercial air conditioning class and BAS. We're now starting to embed BAS into the commercial air conditioning class. So basically that's why I'm here, to see what I can take back to the college and help them get started.
Fantastic.
Good morning, everyone. My name is Eduardo Lesser. I'm coming from Tyler Junior College in Texas. I work my career in the oil and gas industry and switched to HVAC, and I'm teaching there, and we're looking to open this program in Tyler.
Good morning, everyone. I'm David Scott from Elgin Community College, right outside of Chicago. I specialize in renewable energy, solar panels, the whole nine. We're looking to integrate BAS into our energy management and also our HVAC program.
Good morning. My name is Hisham. I teach at Northern Virginia Community College, just outside DC. We're looking to start a BAS class at our school, and we're here to take as much information as we can get to build our own curriculum. Thank you.
And you've got a great start already with a BAS class. You've got the tritium hat to start
I
with.
did the certification 3 weeks ago.
Congratulations.
Thank you.
Good morning, everyone. I am Jay Hines, also from Northern Virginia Community College, an associate instructor there. Hisham already mentioned that we are starting a BAS program, so just looking to absorb and enjoy the experience.
Hello, everybody. My name is Matt Paisley. I'm from Cleveland Community College in North Carolina. I am the program coordinator. The recent program coordinator just retired in December, so I stepped out of the field. I've been out in the field in the commercial and building automation world for about 12 years, 13 years. So just what I'm hoping to get out of this here is to take a lot of my field experience and learn more about building curriculums and how to put all that stuff to kind of together.
Fantastic.
I'm Renee Collins. I am from Heartland Community College. I am faculty there. I get to play with all the cool toys, so that's what we're doing there. I just had the option of starting the first BAS class. In fact, it was kind of here, try this. So we stumbled through the first class, and I'm hoping to be able to pull more information and be able to make that class a little bit better next semester.
Hi, Hi, my name is Haytham Morgum. The easy way to pronounce my name is to say hi, Tim. So it's Haytham. Okay. And I'm managing the HVAC program at Sinclair Community College. We have 2 programs right now, and we are planning on starting a new degree in BAS in 2026. It's going to be 2 years degree. So my goal here is to gather as much information as I can and use it toward the degree.
Where is Sinclair?
Dayton, Ohio.
Thank you.
Hi, I'm Rob McNabb. I'm from North Shore Technical Community College, the Hammond area campus in Hammond, Louisiana. North Shore Technical Community College has 5 campuses across the North Shore of Lake Pontchartrain there in Louisiana, stretching from Baton Rouge all the way over to Covington, Lacombe being our main campus. I've been there since about 2018. We have primarily residential and commercial programs that focus on the light side of things, but we do have 2 courses that are focused on controls. Not a whole program, but at least we have courses focused on controls. But I've incorporated material that I've learned at these workshops throughout my entire program, first in Wyoming and now in Louisiana. And it's a very big part of helping students understand how controls work and how to not only understand controls, but also troubleshoot, repair, and select.
And Rob, by the way, was also at, I think the first time we attended one of these workshops was here at MATC back in 2013. So first year we were here, it wasn't the first one, but now we're ending up here.
Before that day, I didn't even know what these things were. I was a pneumatics guy, so I did not know what these were, and I came to learn more about them. And I just kept coming because every time I go to one of these, I come away with new material, new ideas, also how to present to students. Everybody in the room has excellent ideas of how to present this material to students in ways that they can understand and overcome challenges that they have in the classroom. And the open dialogue between everyone has been critical for me to be able to become an instructor from being a technician. And the Best Center has been a critical portion of that.
Hey Rob, you know how you fix pneumatics?
Get the air back on.
DDC controller and an appropriately large hammer.
Here, give somebody back there.
Fantastic. If you just pass it on down.
Was that the token?
Thank you, Kim. All right. I did a quick intro on myself. Again, Robert Nirenberg. I'm one of the co-PIs here for the Best Center. I am currently out of the Twin Cities up in Minneapolis. I used to teach for a college in Omaha, Nebraska. I was an HVAC instructor and BAS for 6 years there, but I've been doing BAS almost my entire professional career. So I think I figured it at about 21 years now. Interestingly, I actually got my start in controls in the oil and gas industry, working for an oil field servicing company. I learned a lot of things there. One of them was that I didn't want to work in the oil field for very long. So, welcome again, everyone. Next slide, Ted. We already did the overview. Sorry, I got things out of order. Next slide, Ted.
Just like teaching.
Yep, just like teaching, right? How many people get ahead of themselves on their presentations? Right? All right. So, lots of hands-on today, tomorrow, and Wednesday, and then you will be presenting a lesson plan on Friday. As part of your agenda towards the back, there is space for notes. So we encourage you to take notes, just like your students, right? If you write it down, it's as effective as having read it 5 times. At least that's what my English faculty taught me when I was first learning how to teach. Because just like all of you, I came in from the field. I was an energy manager for 6 years dealing with controls. I was a contractor before that, and I'm back to being a contractor now. But we all have to learn how to teach, right? And I don't know about you or your colleges, but in many colleges, teaching the trades faculty how to teach is something that they just kind of do or kind of miss. You know, dealing with lesson plans, lab plans, all those kind of things, they just kind of think you know that coming into it, right? How many people knew that coming into their teaching job? Right? So that's one of the things we try to give you feedback on those lesson plans. That's part of why we do this. That way you have something to grab onto and take home that's concrete, that you can present to your administration, your leadership, to say, this is why I went to this workshop. Okay? Makes them happy, gives you something that you can use back at home. Okay? That's just right there and ready. We'll be helping you work on those throughout. Most of that progress will be on Thursday, of course. Next slide, Ted. All right. Here, we learn as a team. Does anybody in here know everything? Fantastic. I don't have to tell anybody to get out. Because what's the first step in learning something? Having an open mind, admitting that you don't know it already, right? Everybody's had that one student who knows everything. How easy are they to teach? You got to take a couple minutes and break them right at the beginning, right? Torture them a little bit. Make them... that might just be my style of teaching. So, but in here, we learn as a team. Everybody in here knows something that nobody else in here knows. Okay? So, during presentations, during this, one, anytime you have a question, stop us and ask. Okay? We've got a lot of material to cover. Just like in your classes, sometimes we get on a roll and we miss that glassy-eyed look in the students, right? Your instructors. Either you're going to be the best students or the worst students. Don't be the worst students. Ask questions. Okay? Also, when you have something to contribute, please do. If you have a real-world example of something we're talking about, if you have a teaching example of something we're talking about, please share. Okay? We are here to learn from each other. Like I said, nobody in here knows everything. That especially includes me. I learn something about BAS every day. Okay? Always more to learn.
I'm going to go back one slide. Is that okay?
Of course, Ted.
So, this lesson plan, you have access to it already. I sent out an email sometime in the past couple days about you having access to a share drive. So I need everybody to test that out today at some point. Let me know if for some reason you can't get on. Most likely the reason you can't get on is you're logged in as a different email than the email that I had for you. But just let me know, we'll correct that. But this lesson plan template is up in the share drive in lesson plans, and it's right there. Don't write on this one, make a copy of it, and download it and start changing it as you wish. Maybe I should print a copy of this. Would that be helpful, you think? So that you can start writing things right away.
Can you add like our personal email to it? So
I can add whatever you want.
Yeah, okay.
You just need to let me know. Okay? Yeah. So, just let me know.
Yeah, so can access.
And then I'll print off a copy for everybody. We'll get that out sometime before the end of the morning. So you can start writing ideas, the lesson plans you want to do, and thoughts already. So you can start to organize them as the week goes on. We're hoping that during the course of each day, these first 3 days, that you start to etch out a lesson plan based on what we're dealing with today. Okay. That's our goal. But the thing that we do require out of everybody is a lesson plan that you want to take back to your institution and implement hopefully this fall. And you're going to present on that on Friday morning.
And we're not looking for an entire course plan or anything here. We're looking for whatever fits for your program. Okay? Whether it's one lab activity for a BAS class or an HVAC class or a troubleshooting activity for an electrical class, we really don't care what it is, as long as it fits your program. That's the main key. Okay? So.
And this is the actual document. It was developed by one of our network colleges. They had to use it for a particular thing they were working on, so they just gave it to us to go with. You can change the format, look however you want. Okay, that's up to you. And it just kind of goes through, title of it, learning outcomes, parts and equipment needed, reference materials, lab setup, procedures, activities, etc. And part of that you'd have some type of homework, but very generic look. We just want you to start thinking, getting things done. Right?
Renee.
Information in the top corner, is that how we log on to the network and
No. This stuff here is just stuff for the lab here that we have used over the years, and to be honest with you, I don't think we've been using that in the past half dozen years. Because some of it's old already and not even here.
There's only one piece of information on there that's particularly useful, but we'll get to that.
If we're going to get to this, how do we get onto the network to?
Oh, go ahead.
MATC guest, there's no password. You do get jumped to a web page to click to accept their terms and log in.
I'll write that down.
So.
Just look for that Wi-Fi. And you should have pretty good access because the hub is right there. The access point's right up there. However, we have a lot of people in here, a lot of phones. Might be kind of feisty as who gets on. So. All right. we'll dig into the next part. We talked about that already.
Yep. All right. Before we start into this discussion, just a couple of quick, I don't know, infrastructure is not the right word, but details. So all of you should know by now, but just in case you don't, restrooms, out the door, make a left to the main hallway, take a right all the way to the wall, make a left. Okay? If anybody gets injured, we do have first aid kits up here by the teacher's station. Okay? If there is a fire alarm, we will put Rob in charge of knocking down that door so we can get out of here. It's a little bit stuck. Just give it a little bit of shoulder and we'll get out of here. Okay?
He's kidding. Walk out the door here and go out. Or if you really want to, you can go out the door, and that room over there goes outside, and that one's easy to get out. I haven't opened this one up in years, and last time I tried, I started hurting my shoulders, and I'm not trying. I put in a work order for it, but Laura just told me this morning that there actually is no work order in, and I put in like over a year ago, so it dissipated.
We will have a rendezvous spot. If you look right out these windows, you can see a light pole straight out there in the middle of the green. That's where we will meet up for a head count.
That's actually old wind turbine poles.
Okay, I couldn't see the top from here. Thank you.
Well, there's no turbine up there anymore. It kind of blew apart.
There you go. All right. Obviously, you already know where the snacks and drinks are. We will have lunch later today, and that, I think, is still going to be down the hall, correct?
Yeah, but Laura's saying over here.
Here, so it's a little closer for us.
Fantastic. Awesome.
Unless we should think about just getting away all together and going out there. I don't know. We'll see.
All right. So, why are basics important? Sorry, any questions? I will regularly try to check in because, like I said, I get on a roll with things sometimes, but I will ask for questions on a regular basis. This is my way of checking in with you. I will make comments like, does that make sense? This is, again, me looking for feedback of yes, no, huh? When you got questions, ask them, okay? But sometimes, again, I get on a roll and I miss those opportunities, so please ask. We will be doing a number of group discussions. This is our first. Why are basics important? It's the foundation. How do you build up from there without the basics? You don't. End of discussion. Moving on. Now, what else?
The basics is what you fall back on when you're confronted with something that's complex.
Absolutely. When you show up to a problem that looks like Mount Everest, you start down at the basics and go from there. Hey, is the power on? Yeah, have we blown a fuse? All those kind of things that we've learned all along in our careers still apply, right? Why else?
That's your starting point.
It's your starting point. You got to start somewhere, right? How many people in here have taught an intro class in the trades? Show of hands. Just about everybody's taught an intro class, right? Have you ever had a student who didn't know how to use a screwdriver? Yeah. Or a drill? Absolutely. Hammer? You know, it's those basic things. You know, we've known it for so long that a lot of times we take it for granted. But is there anything wrong with them not knowing? No. You don't know what you don't know. So it's our job to teach them those basics. BAS basics, same idea. We have to start down at that ground level. It's a little bit more of an advanced skill, so it's less likely that you're going to have people who do know it, right? But again, you got to start at the base.
Well, sometimes we get classes where it's so unbalanced when we get some high school students and then we got people that want to change careers that probably already know how to use a screwdriver or a drill. So we got to start from the very basic, even though we got a kind of different levels of knowledge in our classes. But yes, we have a lot of high school students who want into a trade, so we have to start with inner basics.
Anybody else experiencing that in their courses, in classes? I think it's universal that we run into that where there's a whole multitude of skill levels. And the one thing that's really helpful is ideally one of those people at the higher level, they're willing to help out the person that doesn't know anything. And you start getting them to interact. Just like you're going to see here, you're going to learn most of what you get out of this material here the next couple of days from each other. So somehow being able to encourage them to help each other is going to be very helpful in a lot of those courses. But it's a challenge. It is a challenge.
It's something that I always share with my third semester students that are almost finishing the program. You always go back to your basics, and I tell them, you always go back, do we have power? That's number one rule. What's rule number two? You make sure you do number one. Do we have power?
Bob could attest to that one, right, Bob? In the IT world, you call for help with IT and they say, what's the first thing to say?
Restart.
Did you plug it in? Did you turn it on?
Yeah.
And they build up from there.
And if you read any manual, you buy a computer, you buy a VCR, say, you go back and troubleshoot, the first thing is,
Yeah.
What's a VCR? Or DVD player. DVD player, what's that too?
Yeah. I learned my first semester teaching not to reference movies because the movies that I experience and the movies that they experience, evening classes with the more adult second career learners, them I was on the same page with. High schoolers, yeah, that was a big whiff. But how it goes, right? You got to figure out how to relate to your students. Every class is different. Peter.
Yeah, one comment I want to make is that BAS is so ubiquitous now that we, as best, we believe that every HVAC program should touch on BAS. And that's why this BAS basics is so important. It's a good place to put that into the curriculum, at least give your students exposure to BAS. And we kind of, our thinking has evolved over the last 13 years. Very few colleges are able to have a full BAS program. But almost every college can at least bring in BAS into the knowledge base for your students. So that's, for me, why this basics is so important.
Yeah, and, to kind of follow up on that, with all the classes I teach in the BAS program, no matter what level they are, I'm still teaching basics. Because that repetition is really important, especially for those who are just brand new to even building sciences. You've got to have that repetition in all your classes. So, get it in there as often as you can is really important.
Mm-hmm. And you don't necessarily have to think of BAS as an end goal. As Peter said, you can put it in just about any of our classes, right? Ted reminded me a couple of days ago of something that I learned and forgot a long time ago, actually now. You can use BAS as a teaching tool, right? How many people learned Ohm's Law as part of your education? Right? Whether it was electrical classes, HVAC classes, engineering classes, you learned Ohm's Law, right? How did you learn it? Math. That's how I learned it anyway. I learned it, I don't know. I don't want to talk about how many times I learned it, so that's okay. But you learn it by rote repetition, right? How good of a way is that to teach in a way that people remember? Some it works for, some they remember it till the test and then gone, right? use something as a teaching tool. Give them a practical application with it. Give them a stick to go beat the idea with, and they'll hold on to it. Okay? You can use BAS as a way to teach electrical basics. You can use BAS as a way to teach networking. You can use BAS as a way to teach programming. Okay? So I challenge you to think about it a little bit different that way this week.
And that's kind of what these boards are about.
Absolutely. So, and these boards, for those of you who were with us last year, Ted demoed his training board, which I think he has one of.
There's one back. There's a whole mess back here.
There we go.
But it's. Gotta find one that I made. So hopefully in better shape. This is just your standard thermostat. It's not even BAS, but a great way to teach the basics. And I do this on our introductory controls class. And this board has evolved into the next step, which this is the first time I built these that you see in front of you. And so it's evolving into a better way, I think, you know, in working with Robert on this, to do the same thing that this does, but a little bit better on getting them into DDC right away. But it's just your basic home thermostat setup and gives them all the basics we just talked about. An important one, at least for some of my partners, industry partners, is the relay. I asked one of my partners, Johnson Controls, I said, hey, what do you look for when interviewing? What's one key item? He grabbed all three of them. I can't remember what the other two are, but relay's the one I remember. It says if they can understand and tell me how to use a relay, they're likely to be hired. So we can use these boards to help teach them some of those concepts and get them in the door a lot quicker.
Do you provide like a wiring diagram for this to students?
Yeah, actually, when I teach this, it's introductory to controls class. It's electrical concepts and introduction to controls. It's 143 up in that list there. What I do is I provide them this board. There's 10 of these boards being up on the side. Each desk can have one. And working groups to use that board. Then they have to go in the back there, get a piece of plywood, and start building that piece up. And that's what we're going to talk about over the next couple hours here, is doing that type of process, but applying to this instead. And they have to drill through their own wiring diagram. I write it up on the board. I also have a print off I can show them, or they can have access to. But they have to do it, draw it in Visio. So yes, I give just an introductory class. I give them everything, so that by the process of them going through and adding one item on at a time, week after week, it embeds it in their head.
Brad, you do that too with your class, don't you?
Yes. In our program, as I stated, 4 semesters. In the first semester, the students are introduced to electrical and electrical circuits. They learn how to recognize symbols, wiring diagrams, and components. Series of parallel circuits. The second semester has an electrical controls class. And right now, Richard Gentry, our department chair, he's the instructor of that class. I'm in the process of redoing the intro class. And I've got 2 automated controls classes that are on the other side of our electrical controls class. So Richard and I are going to work together because he now has the bookends. And I need him to fill in because the students that are coming out of his class going into my automated controls class really need to be strong with electrical circuitry. They are in the 4th or 5th week, they start wiring projects that they have to create their own wiring diagrams in Visio. And I provide them the manufacturer's data sheets
and wiring diagrams. And they have to convert that to their real application. And by the time they get to the fourth semester, they have a really good understanding of electrical circuits, because in the controls industry, we've got multiple circuits that work together with one another. They have to be totally isolated, because you might have a 0 to 5 volt DC or 0 to 10 volt DC, 20 milliamp signal, 120 volt control circuit, 24 volt AC, and even a 460 volt. They have to understand how all of those work together. And by the time they get to the fourth semester, they really have a strong understanding of electrical circuits and the components. And one of the most misunderstood is that little control relay. And again, it goes to the repetition. The first semester, second semester, third semester, fourth semester, they're exposed to it. And each semester, it gets more and more complex.
Awesome.
For Visio, does your school provide the license for the students, or does students purchase the license themselves?
All of our computers in 2 of our computer labs have Visio 2016 on them. The students, and actually I provided a link that one of my students sent me. There is a link out there, and if anybody's interested, I can provide it, that the students use to purchase it for under 20 bucks.
That would be very helpful to me.
I think it's 30 now.
Is it?
Yeah.
It's been a while since I bought it. I mean, Omaha, when I had to crash and burn mine.
Yeah. So, Brad, actually, we will create a resources folder in that same drive link where you can find that lesson plan, and we will start adding things to that folder as we go. So that'll be one of the things we add. Okay. And that actually, Brad did a brilliant transition there for me, thank you, to the next thing we need to cover about basics. When do we teach basics? Say it again louder.
Every semester.
Every semester, right? Because repetition. What's another thing we teach every semester? Safety, right? Because we have to hammer those things in because they're critically important. Okay? But more broadly, when do you start teaching BAS in your courses? Where does it fit in your program? It may not be a day 1 class or a zero or semester 1 class unless you have an entire program, right? For those of you who are including it in as part of your HVAC or electrical or something like that, curious, where do you teach it? When do you start talking about it?
The last semester for us, I think we teach BAS at the last semester, simply because you cannot control what you don't know. Basically, we teach the fundamentals, then we start with networking, and then
terminology too. You got to cover the terminology. If they don't understand what it is, they won't understand the basics, right?
Right.
So I think terminology is something that I kind of hammer there first.
Vocabulary. Yep. By the way, we use a lot of abbreviations for those of you not familiar. A lot of abbreviations. Here at BEST, we like the term BAS, Building Automation Systems, but it could be Building Management System, Energy Management System. DDC is the overarching term, Direct Digital Controls. They were the replacement for Rob's pneumatics. I pick on Rob a lot. We've been hanging out for a while, so. Okay. Where else do you teach it? So we've got a last semester. Where else? Laura.
I don't teach, but I would think in every class, even if it's just a brief touch base on let's go back to the basics, and how you build upon that for whatever class you're teaching.
Valid. How many people teach BAS in relation to residential? Got to introduce them to it, right? How many people teach smart thermostats or smart home systems in their residential? What do you think that is? BAS, right? It's the same thing. How many people teach zoning systems for residential or commercial? It's BAS. It's specific purpose, but it's still BAS, right?
So really it's real appropriate because you should be touching it from your startup, from introductory to refrigeration, all the way through the residential side, all the way through heat pumps.
There you go.
Packages, you know, so then you move on to commercial, then you can get more in depth in it, but it should be in every single, you should be able to tie something BAS related into every single module that you run.
I like that because it applies. Again, it may not be your goal to teach BAS, but it can be a way to teach what you're trying to teach. Also, before you started teaching, show of hands, how many people knew what BAS was, whatever nomenclature you need for it? Okay? Keep your hands up. How many people, for those of you who were in operations, you took care of buildings for a living, put your hand down. Okay? For those of you who were engineers, mechanical, electrical engineers, put your hands down. How many hands are still up? Uh-huh. So if you didn't take care of buildings, if you weren't an engineer in this group, you didn't know about it. The only reason I knew about it was because my dad was an electrician and got hired by a controls company. That's the only reason I knew. I actually came to this, by the way, from computer science. And I heard someone say you can't control what you don't understand. I disagree with that slightly. You should understand it. And that's our goal with teaching BAS. But if you're not teaching it, those people in this class, if you're not teaching it, who else do you think is teaching it? So just exposing students to BAS is critical. Because yes, there are a huge number of jobs out there in HVAC, service, installation, residential, commercial refrigeration. Great jobs, right? And they all got to get done. We don't have enough technicians for them. But what happens when we get into the specialties underneath each of those? Anybody had to work on chillers recently? Or had to have a chiller worked on? How long do you have to wait for a tech for that? A while. The bigger the chiller, the more specialized, the longer it takes. Well, BAS is a specialization too. The thing is that BAS is one of those specializations that's as common in commercial buildings as ductwork and piping.
And depending on where you live, you're going to have outsourced.
Absolutely. Anybody know how much, I'm going to pick on Johnson because they're right down the road. Here in Wisconsin, anybody got a guess how much Johnson Controls charges per hour for a controls service tech? Speak it out again, Kelvin. About 300 an hour. Laura? 200 an hour. Anybody else? Split the difference, $250 an hour. They do. Johnson, because they are largely the corporate side of it, does most of their work, and they're expensive. They are not, they're probably one of the upper end outliers. But you know what? Brad, what do they charge in the Bay Area?
Probably $250 an hour.
See? $250 an hour. Bay Area is a little more expensive, of course, than around here, but it's still ending up in the same number. Okay? Where I did most of my work, Omaha, we're looking in the 120 to 150 range for everybody but Johnson and Siemens. Okay? These are expensive tasks. And why are they so expensive? Not a lot of people doing them, specialized skill set. Combination of those two things. Buildings, owners, managers are trying to learn more and more about BAS because it is so expensive, so that they can do some of the stuff in-house, which is totally reasonable. If your students are learning it in class, maybe they're taking HVAC classes. What about building operations? You know, if they, get a back injury while they're young, are they going to want to be carrying compressors up onto roofs, installing ductwork all the time? No. So they've got to figure out an alternative. So it's a backup plan in some cases. Laura.
Yeah, I can speak to that. So we tried hiring a building automation system programmer at ATC. It was a fight to get the position, finally got it open, trying to find somebody to fill it. Absolutely difficult. We are now hiring Johnson Controls for 40 hours a week to do that work for us. It gets us a better rate, but it's still like $150, $160 an hour that we're paying for that because we could not find someone to do it. And I hire them directly.
How much did you offer when you opened the position to hire someone?
The range was, the way we post is not ideal. I want to say we posted from $85 to over $100,000.
That's actually pretty good wage for an operation side,
Because
I
at
bet.
first they tried to post it for 65 and I laughed at them and said, no.
Yeah, because I was about to say, if you listed for 60, no one gonna even apply for it.
Absolutely right.
And the surprise was, we had former students I was trying to encourage to apply, and couldn't get them to apply.
Mhm.
It's just,
That's a good wage.
Yeah. But in certain fields, 60, 70, 80, 100,000 is not actually a good wage. It's laughable when you can go make $70 an hour with benefits on top of it.
yeah, sheet metal people coming out of their apprenticeship, they're making 90 to 100 here in Wisconsin.
So, does anybody in here have, I know we've got a couple folks who are working on a full associate's degree for BAS. Could I see a show of hands? Or if you already have an existing, either one. Okay, two.
So I saw 3 or 4.
People aren't raising their hands up high enough then. Show them again. Hands high. 2. Okay.
I probably saw yours up for.
I thought, then you said BAS, mine's an HVAC.
Oh, okay. All right.
Okay. How many people have a certificate or diploma or whatever specialized term your institution uses for those handful of classes that aren't a full associate's degree related to BAS?
Work in a process.
In the process counts too.
5, 6.
Triple the number. 4 times the number. Okay?
Yeah, and the difference there, the reason that we're asking, or I put the question up there was, where are your basics covered? And maybe there's a little bit difference in basics between the 2 different programs and where you teach it. Kind of depends upon how you set up your courses. Quite often we'll set up our diploma to feed right into the associate's degree, and so there's really no difference there. But is there those that raise their hands?
So, if we end up offering some sort of certificate for it, and we are a 2-year program, right? So they will have to take 4 classes, so they will have to start on the first semester, the first day. Since we only have 1 section of each of the 4 classes.
Yeah.
So we don't know if that will work out or if we can do it. That's why we're still not sure if we can get the certificate for it or not. I don't know how you guys do it, but when you start it.
Yeah, well, the way we've done it is we have, we wanted to start up a BAS program here at the college. And so we went to industry. Industry said, we don't want an associate's degree, we want a diploma. So we started a diploma right away. And then after we got the diploma set up, we built these certificates, or they're digital badges. To me, it's kind of the same thing, but there are nuances, right? But the digital badge, there's one that's geared just for controls. So it's kind of that step into digital controls. So we kind of backed into that. And those courses apply directly to the BAS program. We also have 2 other programs which use our classes. One of them is power engineering. They have the introductory to controls class as part of their program. And then we have the facilities maintenance technician apprenticeship program. And they take a couple of our classes here.
When you say power engineering, what do you mean, Ted? Steam
Out in
operations?
California, like to call them stationary engineers, people who operate that, what I refer to as the heavier equipment, the boilers, the chillers in the buildings.
Thank you.
Is these backed up or sponsored by someone else, or it's just endorsed by a third party, or just your school?
Just our school. The certificates, just our school. We just put 3 together based on our advisory committee, which is all industry partners, said, well, put these 3 together and make it a control fundamentals technician certificate or a digital badge, as well as they said, make this a 1-year diploma program. So I don't know if that really means it's backed, but.
In May last month, our Division of Workforce Services approached me about exploring doing an NC3 certification through training, and we had preliminary meetings with them, and I asked them for our equipment quote. Their equipment quote was $530,000 initially, mostly labor for as built. But that was my goal, is to get that quote, and I was able to relay that information to our head of workforce development because they wanted to put some kind of BAS certificate. And I told them, however, with the equipment we have on hand and our accreditation, we can offer HVAC excellence employment ready certification in BAS, and they want to pursue that. And so we are in development, but that's where the point we're in conversations right now. And right now the conversation turned towards that HVAC excellence because of the sticker shock of the NC3 and the fact that the trainers were trained, we couldn't program or anything. It was all proprietary. It'd just be watch it work. Whereas I have 2 separate platforms in my lab, and they can go from starting from ground up with both platforms. So.
Carry on. Yeah, I was thank you for mentioning both of those institutions, because I was going to reply on that the only 2 BAS certificates or anything that I have heard of so far from educational based are, one is from NC3, which is a train based certification, and the other is from our friends at HVAC Excellence. They have an employment ready exam for BAS. I've heard some interesting things about it. I haven't taken the exam yet myself, but I've been hearing some feedback that maybe it's a little bit more than employment ready and headed more towards journey worker kind of levels of knowledge. But that's just what I've heard. I am working on blocking out the time to take the exam myself to see what I think of it, but we'll see.
I haven't taken it either. I have severe chest anxiety. I have too many certificates that probably flagged me when I went there to take it.
Yeah.
Interesting thing is, so $500,000.
Yeah.
You get 12, 14 of these for 15 grand.
Right.
You can make it yourself.
Right. Or when I built my lab for less than $20,000 was.
Yeah.
Which I'll feature some pictures on Tuesday morning. But
okay.
It's so cheap.
Yeah. I've been doing controls for a long time, and that quote for $500,000 it is mind-boggling to me. That's the controls for this building. Labor, parts, everything. Well, maybe not from Johnson, but there are other certificates in the controls industry. And I want to make you aware of those, but also caution you. So you just took the Tritium, the N4 certification, right? First off, who did you take it through? Tritium. Through Tritium directly? Yeah. Because they're right there in Virginia, so that makes sense. Okay?
I was about to ask you about that later. They were open to the idea of endorsing our program as a pre-TCB certification.
That's
so
interesting.
It's in the talk. We haven't really nothing solid yet, but they were open to it.
That's really interesting.
Yeah.
That's not one that I've heard of getting an endorsement from them.
I proposed it to them and they were open to discuss it.
Fantastic. Could you keep us updated at best on how that goes?
I don't have the Surface Bench software and they no longer sell it. You have to subscribe to it on yearly basis. And if I want to get it for all my students, it's a lot of money. I don't think we can afford it.
Are you talking about the workbench?
Yeah, Workbench, yeah.
I've been working with Reading now for over a year to try to get our students certified, and it's a ton of money. And
yeah, but do you have the Workbench software?
I do. We do have Workbench.
How many? Like
we have 20 licenses in our lab.
Do you buy them one time or yearly?
Well, we have huge support from our industrial sector, so they pay for it. It's donated to us. So the companies
annual.
Huh?
They pay annual.
Yes, companies donate this to us. So we have very good relation with Point to Point, while other companies, Johnson, so they provide us with it. But when it comes to the certification through Tritium, they will ask for, like for example, after everything, if you want to certify a student, you have to pay for them something close to $1,000 just for each student.
That's if you want to do the full certification. Correct. So for anybody who wants Niagara stuff, talk to me after hours. I can help with that. So, but the Niagara certification is a really great example of what the controls industry does. So the Niagara certification is a week-long certification if you take the in-person class. You spend 4 days learning how to set up their hardware and software. You spend about half of the first day learning what their terminology and what their offerings are, and then you spend the next 3.5 days learning how to do everything. Everything are very big quotes. There is so much that they don't teach you that it's ridiculous. But you would expect that from a 1-week training. The last day of the course is their certification test. Okay? If you pass that test, congratulations, you are N4 certified. Does that mean you're actually good at it? Practiced at it? Ted's N4 certified.
Don't want me working on your Niagara.
Right. And I'm not saying that as a degradation or anything. So all of the companies that I have ever seen their certificates from, Johnson Controls, Schneider Electric, Siemens, Honeywell, Tritium, KMC, it's all the same. You take a class for X number of days, you take a test at the end of that class, and congratulations, you're certified to sell it, or certified to install it, or certified to service it. You know what they don't teach anything of? Can I, oh, hey, we've got the word right there. Perfect. They don't teach the basics. They don't teach what an input is. They don't teach what an output is. They don't teach you anything about electrical.
Don't require experience or certifications?
No.
No, they don't. And sadly, they don't. All you have to do is take one online, like, and it's unlimited attempts till you pass it, and then you pay them $5,000 or $4,000, and you own it. That's it.
It's gone up.
Yeah.
I think it's 3,650 when
Most of the manufacturers expect a technician to have been working for a controls company for a month or less before they go and take this certification.
I have done it the same way Hisham did it. I'm a mechanical engineer guy, so I jumped to the certificate. I went there. It was very miserable, hard week, because as you said, they will teach you everything before then they will give an exam. They won't explain to you what's the digital input. They don't teach you much. But right now they have the operation we call Niagara Operation Certificate. So if you want to learn about control, you start with this. Start with the Niagara Operation Certificate. They teach you how to wire, what's the points are. They teach you the basics. It's a new thing, I think. Then you can go and do the certificate. This is the right way to do it. So start from lower level course, so you get the most out. Again, the basics.
Right, and it's taken the controls industry 30 years to figure out, oh, maybe we need to do that.
Yeah, but you have to keep in mind that TCB is a software certification for the
Exactly.
software. It's not really a
And that's
control certification.
that's exactly it. All the certificates you catch from the controls manufacturers, which there are, I'm not saying their classes aren't good. They are really effective at teaching what they want to teach. But what they want to teach is the usage of their software, their hardware. So be maybe cautious about doing that for your program. I'm not going to say it's a bad thing for your program, but you have to make sure it's your responsibility to make sure that it's the right answer for your program.
Well, the things that we've been kind of pushing the way where they want us, well, our college is looking for certifications, not only just completers, but industry-based certification. They want the student to finish, and with what certifications? So
Right.
we have to be very mindful of handpick what those certifications. That's why I'm here too, just to see what kind of certifications are out there, so I can take it out there. Probably, pick one and then stick to it. However, it needs to fit the students' needs, and also because of the lack of experience, they're students, and that makes it a bit more challenging.
Absolutely.
There's
And
few and far between them.
And
right?
yeah. Well, there are many of them out there. Every manufacturer has one, or almost every manufacturer has one or two. But most of them, like the Niagara certification is one of those pinnacle examples, it's expensive. They won't give it away. You can buy all of their hardware and all of their software and spend 2 years teaching students how to use it, which is probably more effective than what they do. But at the end of it, if you want them to have the certificate, it's going to be cash on the barrelhead. To the cheapest I've ever heard Niagara making a deal for it, and I've been working with Tritium's products for a long time, was $1,000 a head. Peter.
Question, what does the real world look like in terms of the control systems that a typical campus has?
So I'm going to give an example. A few years ago, I worked on a hospital in Denver. It was predominantly a medical office building. It was built in the mid-2000s, so it was just under 20 years old at the time. And it had 7 different controls manufacturers in one building. It was about 250,000 square feet. So it was not an insignificant building. 4 or 5 floors, had a lot going on. Really pretty basic systems for the most part, bunch of VAV boxes, rooftop air handlers, hot water, chilled water system, nothing wild and crazy, got a little more in-depth in the operating rooms. 7 manufacturers, and the building was less than 20 years old. And that's manufacturers. I'm not talking different editions or versions of the controls. It was predominantly a Siemens system, and that was 4 generations deep. Okay? That's maybe a little bit on the extreme side, but really not that much. Unless you have an organization that is really very focused on maintaining a single control system, you usually end up with multiple systems, especially in governmental institutions, because of the misconception of lowest bid requirements, or maybe the misapplication of lowest bid requirements. Renee?
On that, we've been talking about BAS being an HVAC system. So are there any systems, or does anyone work with any systems that use HVAC, lighting, security, networking, all those bottled into one more as a smart home or a smart industry building, rather than just HVAC?
Every manufacturer will tell you, yes, we do that.
We don't.
Most do. It just doesn't work as well as they claim. Siemens has a big overarching system that covers lighting, HVAC, security, and cameras that actually does work together reasonably well. I don't think they're quite to the point where you badge in the morning and it turns the light on over your desk, but that's mostly because nobody takes the time to program that. Johnson has a similar variety of systems. Schneider and Honeywell both have companies underneath them that provide all of those disparate services. Most institutions don't end up going that route because of a combination of cost and complexity. And what's that?
Need.
And need. The places that do tend to go heavier in those type of systems often are the buildings that really want to be the best. We want to be that advanced. Apple, Google, places like that. And also hospitals are the other ones that tend to go more towards that level.
One more question. What about the accreditation? Right now, we are EBIT accredited, and we are moving from EBIT to another accreditation. So if we are, with this new program, what do you think? What accreditation that BAS promotes?
So right now, I am not aware of anybody who has a functioning BAS accreditation. I know HVAC Excellence is working on it, but I don't believe they have completed that. And I'm going to call Larry. Hey, Larry, do you know if HVAC Excellence has finished the BAS accreditation yet?
I don't know its status.
Okay. So we don't know. Do they offer the accreditation now?
The accreditation packet for you to try to get accredited.
For HVAC or for BAS?
For BAS.
Okay.
I can
So
verify that by jumping on their website.
would you do that for us? Thank you, Rob. Because they are, to my knowledge, the only institution that's doing it. There was a group a number of years ago called the Association of Controls Professionals that was working on an ISO level certification, but that kind of lost momentum and funding. So.
HVAC Excellence, HVACR, BAS, and Green Mechanical Systems are the three accredited program areas.
Okay. So that, say it again louder. HVAC.
HVACR, BAS, and Green Mechanical Systems.
Yeah, BAS was the second one. I knew they were working on it. I didn't know if they had finished it or not.
So it is there?
Yeah.
Seems that way. So that would be the one I would look at. I know NC3 offers the certificate, and you heard the price tag. So past that, I don't know of anything that isn't, or that is that level. Honestly, out in the controls industry, it's those career certificates, program certificates from you, associate's degrees, things like that are useful. I'm not going to say they're not. But a lot of times control companies are so desperate for help, you need two things. One of them is a pulse. And the other, of course, is that one that we're all familiar with, which is passing that pre-employment test of whatever your state is appropriate for.
I was going to say initiative to just apply, because that's about it.
Yeah.
I'm asking this because, as you know, for a graduate, for a technician to work in a federal facility, he has to be graduated from an accredited institution. So that's, I'm not sure what's the case with the adult information system certificate, but I know that for a fact for the HVAC degree. So if the student graduated from institution that's not accredited, he cannot work in base or any federal facility. So that's why I'm asking.
Wow, I've not heard that requirement, but that's good to know. I will state that I don't think that that's universal across all federal systems. But as far as BAS goes, there are so few institutions hiring it internally that it's just going to, hey, contractor X that does our controls work, send us somebody. And that's how it gets done.
So I want to step in for a second. As we're going through things, we mentioned HVAC excellence, we have a website. I want to encourage everybody here that, as things come up like that, a link to a website or whatever, there is a place on the share drive that has links to files, websites here. And you can open up that particular item and it'll take you right to this. And I just put in HVAC, link to HVAC excellence as we were talking. And everybody is welcome to do the same thing as we talk about different things, especially if you work in your groups and not sharing, and the whole group doesn't hear it, okay? So please, I want to encourage everybody to do that, because there's things that we'll be talking about that we just haven't captured here. And I know that between Rafat, Brad, myself, and Robert, we've talked about way more than you see up there, probably 20, 30 different sites already in the past several weeks, and we don't have them here. So let's get a document so we can all share this information. You'll have access to this when we get back. I don't know how long we'll keep it active, but it'll be active for quite a while. So.
Brad, would you mind putting your Visio link there? Thank you.
Yeah, exactly. So now you said that, what are you going to do, Brad? What's that? What link are you going to put up there?
The Visio.
Visio. Oh, so everybody heard that already?
Yeah.
Okay, all right. I just want to let people know, because we want to share information. This is a good way to do it. As annoying as Google can be at times, it does serve a pretty good purpose.
Yeah, just a note. Rob was saying that NC3 is over $500,000 for their lab. What do you have here? How much did this cost?
So these two rooms are just normal classrooms for our EMTs. And so we spent, I think it was $250,000 to $300,000 redoing these rooms overall. So there was physical stuff we had to do to the rooms, knock down some walls and stuff. And we had to do some work on the fire protection system because we wanted the ceiling open. And so there's that type of thing. But when you talk about just the physical things you're looking at, the piping, the air handling units, and the control equipment on here, we're probably talking on the order of $150,000 to $180,000 worth of work. And I believe a lot of that, well, I know a lot of that was done by the sheet metal apprentices as part of their classes. They helped put these things together.
Yep.
So, it's a chunk of change.
Yeah, nothing like $500,000.
No. And it's more than just controls. We have trainers and all this other stuff. We had to get these tables. That's part of the cost.
Yeah. I don't know why I thought NC3 was a low-cost alternative.
We had a lot of wiring gets done in here too, electrical. We went on new lighting in both rooms. The rest of the LEDs now. Yeah. So there's a lot of things like that.
And on Best Center website, we have lab tours,
Mhm.
and we have some documentation of labs. So-
Yep. So,
You got more?
probably.
Probably?
Yes.
How about if I jump into what I wanted to cover before we go on a break in 7-8 minutes?
Go for it.
So, as far as the basics, we're going to talk about these
It
things
should
all
be
day.
in your email already.
You're going to be doing hands-on with these boards.
Look for
okay?
one from Ted.
As you go through these boards, one of the things that
I'll make
do
him
with
resend
our
it.
introductory class
I'll make him resend it.
is to go through, as they're going through the thermostat trainers that I showed you earlier. I touch on all this stuff except for the controllers and programming part of it, the last item. Everything else, they do in that first class. There's modules that we have that I developed on these that, we say they're developed so I can use them. People, there's a lot of stuff I know to talk about when I'm doing them. But I can share what I do have with you. But it will cover electricity with these boards. We're covering signals, binary, analog. And on electricity, you talk about powers and the power and some signals that we're using. Mechanical equipment. So not only talk about controls, we're covering, okay, what do you control? You've got to understand that. And even in this basic control class, we're talking about those things. We have all these other classes that work on helping support that. But still, we're talking about sequences. How does it start? And you think you flip a switch and it comes on. Well, it's not that simple. There's a lot of stuff that goes behind that. And they learn that basic thermostat. Wiring. So that they have to build this board themselves, so they're doing all this wiring, which those motor skills are really, really critical. It helps them learn as they're going through all that. Devices. What type of devices do we have? What are inputs? What are outputs? We're covering all that. The schematics, learning about using a software package to draw it. We use Visio here. You probably have something different. Maybe you use Visio. I don't know. That it's a very, I don't want to say it's crude, but you have to develop a lot of stuff as you go. And I'll show you, as we go through today, I'll share some of these different files that I have for them already developed, and you can take and modify them as you see fit. And they have to draw that as they're building. So 1 week I'll have them put on the transformer, and then they got to draw that week too. So each week I kind of build on it. And this is a 8-week class, and it's 2 nights a week. So they're constantly doing all these different steps and all these different parts, learning it over and over and over again. So that hopefully by the end of that course, it's kind of helped embedded into their mind. I was criticized in the beginning about being very adamant about we got to have my software. I don't care if it's Microsoft Excel, Lotus, Google, Word, whatever. They got to be using and familiar with all these different types of software, especially the stuff that's industry specific, right? So that they can get around in the next piece of software they got to use. If you don't understand all those basics of that software, you get back to basics, they're never going to be able to get to the next level of what their career is. And so I've convinced these people over the years, right, Ted? You're right, Ted, on doing this. Keep pounding that in so they have this skill set. And the drawing's no different. The drawing, besides the fact that you're used to using the software package, it's given another kick at the can from a different direction to understand the basics of their controls. So it's really important that they're doing, in my mind, they're doing all these different steps as they go along. It provides a much better student. And I cringe to think about how I taught that class 8-9 years ago compared to what we do today. There's no comparison. And it's made a big difference, I think, in the quality of the technicians coming out of the program. So, as you're going through today, tomorrow, and Wednesday, think about all these different things that you can incorporate into your lesson plan that you want to do. And when you think about your lesson plan, you know, you may choose to just talk about the hot water valve. And we're connecting the hot water valve today and step through all that, but try to hit on one of these different areas and just keep that going in your mind, jotting down notes, and I'll print off copies of that lesson plan. I know it's just an outline, but it'll help you, I think, to get some idea of what you want to do as the days go on here. So that's where we're going. We're going to fall back on this. Did you have anything more you want to talk about before break?
I have two things before the break. One is I just want I'm curious. Can I see a show of hands? How many people teach in your program how to read an electrical diagram? Okay.
Yeah.
How many people teach how to draw an electrical diagram, even if it's just a basic diagram? Okay. How many people use some piece of software to do it in a digital format? Does anybody use anything of you four? Do you use anything besides Visio for that? Go on, Renee.
It's not PSpice anymore. It's an electrical.
Multi-sim.
Yes.
What was that?
Multi-sim.
Multi-sim?
What's it called?
Multi-sim.
Multi-sim?
For those of you who, I just wanted to see if there was any other software that people would suggest. Is it easy to work with?
Yeah.
They also have something called Transfer. It's a company that has that same thing, but it's inside of the VR goggles.
Okay.
I'm actually bring over to that. Cool.
Very cool. Thank you, Kelvin.
There is a free version. I have to find it.
Aha! That's a word we love. Free, right? For the most part, most of our usage, we need basics, right? For drawing. So free may be just what some folks need.
And, you know, by the way, those drawing packages, and most people using Visio right now, it sounds like, you got to build your own particular equipment in them and stuff, because they have very elementary level symbols, icons. Let's share that in that Google Drive so that everybody has access to what you did if you're willing to share it. And that's why I put mine up there already, so that you have access to it. You can grab what you want and do what you want. So.
Everyday Circuits. That's the free version? There we go. Could you put that up in the link or in the document when you get a chance, Renee? Fair enough. Ted, would you mind resending the share drive link sometime this morning? Perfect. So the other thing that I had was one more quick thing, then we'll take a break, I promise. And that is not the one that I want. Justin.
Hey.
Stand up.
Oh, okay. Hey everybody, my name is Justin Haynes. I'm Director of Building Automation at GPTC, Georgia Piedmont Technical College. That's down there in Clarkston, which is basically Atlanta, Georgia. So, let's see, hope you got this experience. Well, this is the last one for a while, I suppose. So, I do like that we're talking about Visio a lot. I want to get more into that and want to see how I can incorporate that more as I go along teaching for as many classes as possible, really, as early as possible. Because I feel like Visio is probably one of the most important parts of teaching students about electrical circuits and just their understanding of layouts. So yeah, that's kind of what I want to know more about.
Fantastic. Thank you, Justin.
Yes, thank you.
And I know I said one more thing, but I meant one other thing. Case. Anybody heard this term before? Copy and cite everything. Okay? There's an alternative to cite. And it's much more associated with that other definition of case that you may be familiar with, as in casing the joint. Anyway. All right.
One more thing for me.
Not my fault, his fault.
My fault. Back by Laura, there's a tool cabinet. The third drawer of that tool cabinet has stripping pliers in there, wire strippers. And there's screwdrivers in the second drawer. All the tools we're going to need are in there. If there's not enough, let me know. We'll get some more for you. But here's a list of things that we're going to start working on before. We want to start hitting this up during break. Please feel free to. Okay. One of the things is that the 12-volt power supply right here. Some will have this already stripped, but everybody's got to get theirs stripped down to the 2 wires. So you got access to the 2 wires. Okay, just cut the end off. It's okay. And you want to lift yours up, Eduardo? Show them what it looks like. See, his is already stripped. You might want to get a little bit more. Oh yeah, you got a fair amount there. Yeah. Let's get it stripped down to that level so you have access to that. Figure out how. Look at the relay on there. Make sure you understand how to do that. Up on the Google Drive. I probably got to get it into the shared folder, but there should be a diagram of how to do it. I'll get that up there in just a little bit. Oh no, relay information's up there. It'll show you, because I don't know about you, but my eyes aren't this good that I can read this very easily. So I got one up there. You can look at it. Okay. Thank you. So we got that. Then you're going to have to wire the temperature sensor to UI. Well, I never did UI number.
UI1. We will be discussing all of that afterwards, so this is just if you want to work a little bit ahead during break.
Yeah.
If you would grab your tools before we come back at 10:15, that would be appreciated though.
Yeah. So,
do you want us to leave anything to reuse that end? Are you going to reuse the end, or just snip it off?
Oh, just snip the end off and throw it away.
Okay.
Get it out of here.
Okay.
It's more a pain, causes me more problems to have it than not to have it. Okay. And I learned that with those trainer boards there. So I thought, I got to make sure I have access to use that for other things. But no, it's the purpose is to do this stuff. Thank you for asking. Appreciate it.
All right. Anybody have any questions before we go on break?
The wiring diagrams, you're using it for complex systems as a simplification of a process and the control.
I'm not, Ted.
Yeah.
Hang on, folks. We got a question.
So, can you ask a quick again?
So, the wiring diagram will relate to everything that's electrical, but in complex system where we have different kind of sensors, and we need to also write down what are the parameters of those sensors.
It can definitely be used as a tool to document that, to help make sure that you check all the details that you got all the sensors. It can also be used as a tool to teach sequence of operation.
Okay. Process and control diagram.
Yeah.
That's something that we introduce at the highest level.
Yeah. So keep in mind, we're back at basics right now, but you can take it to the next level.
Yeah.
During break, I'll pull up the wiring diagram for those boards there, and you'll see it looks really complicated on the screen, but it's really not. Which this one here will be just as complicated. And I know it looks like a spaghetti network, but when I first build a board, first time I do it, which this is the first time I did it, even though I did it 14 times, it's a mess. It'll get better as time goes on. All right. And allow yourself that when you start doing stuff, it's not going to be pretty when you first do it, but over time, it will.
All right.
And that's where you want to get your students. Break.
Break. Come back in 9 minutes. Could have been 30 if I'd quit.
We brought him on as my boss about 3 years ago. That's been even better. I was gonna say, Ted is really good at spinning a web. If you haven't figured that out by now, so. I did want to say welcome, good morning. Thank you all for attending. So, my name is Dave Stewart. Official title is Director of Apprenticeships and Special Projects.
That's me, special project.
Yeah, isn't that the truth? For the college. So, I recognize a few of you. So, good to see some familiar faces. When I first, oh boy, this is really official now. When I first started with the college, I was an instructor for sheet metal apprenticeship. Ted brought me in on the Best Center stuff early on. I know we went to Atlanta together, California once. So Best Center is doing great work. I love it. I'm happy to support in any way we can. And so welcome to MATC. Hope you have a great time. Got any questions, concerns, comments? My office is right over there. I'm around. So thanks a lot.
Thanks, Dave.
Thank you. Whoop. Sorry. Have a good one.
Thank you.
Good seeing you. How you been? Good.
I actually meant it. He is a really good boss. I really like him. So.
All right. We ready? All right. Did anybody think of any questions over the break?
When you're getting all this material, you're making a curriculum, or they're getting started, how much do you rely on a book or versus OER?
That's a great question. So, just to make sure everybody knows, OER, Open Educational Resources. I'm a huge fan. I haven't found a textbook that I liked for controls yet. There are some that have been written by or published by ATP that are okay, but they haven't been updated in a long time. Like, there we go, 2013. I was going to guess somewhere in the 10 to 12 year range. So they're the basics, don't change that much, but some of the stuff later on may be a little bit dated. So I personally, big fan of OER. I lean very heavily on the manuals for the bits and pieces. They're good at teaching the electrical wiring concepts. They've got, I'm not going to say they all have good wiring diagrams in them, because some of them, the wiring diagrams are absolute garbage, which is fantastic for a teaching tool, because you can show the students, hey, this is the kind of thing that you have to deal with sometimes. It's a challenge for them to figure out. It's also a good example of what not to do when you're doing something, like a diagram. So,
aside from ATP, which might be considered like a textbook, right?
Mhm.
Do you have any other resource that you can share that we might have, we could have into our library, that we could, as instructors, we can share that and have the students check out electronically per se, and utilize that.
Can I comment on that?
Of course, Arnaldo.
We're, like I mentioned, currently trying to embed BAS into HVAC. So we're working with Brian Lovell.
Mm-hmm.
And the way we're doing it is that we've got the BAS thing all set up where you can get through ACP. But anyway, we're going to be embedding the modules in our first semester electrical classes, and then into the intermediate electrical classes, and then finally into the commercial classes. And they'll get credit for, eventually we'll be offering a BAS degree, I hope. So they'll get credit for those classes towards the BAS. And he's got curriculum built into every module.
Yeah. Brian Lovell, for those of you who don't know, Brian Lovell was one of our PIs for a long time here at the Best Center, and has a company based out of Atlanta called Base Labs. Still the right name? Yeah. Thank you. And he's got a number of trainers that are available. He has a lot of curriculum developed for those trainers. So that is definitely an option. There are a couple of other companies that have trainers out there as well, some of which do also have curriculum. I think iConnect has one, or actually iConnect has 2 or 3. Yeah. Be forewarned, sometimes those trainers might offer some sticker shock. I don't know what Brian's pricing is on those, though I expect it's probably better than most of the others.
What was the other one that was?
iConnect or Base Labs. Okay. So there is curriculum out there. One of the links that's already in that sheet is by the manufacturer Contemporary Controls, that's the controller that's on your board. They have a number of educational resources. They've got a lot for networking, but they also have some control stuff as well through their site. Also, Tritium University has some free stuff on their site, so I encourage you to check those out too.
Oh, so the question is, what's the value of doing it in this fashion here? And, you know, it's probably half dozen one, six another type of a situation. But for me, the value of doing it like this is it requires them to do everything from scratch. They have to find the materials, they have to wire it, they have to screw things down. So it's, to me, it's a really good basic learning way to do it. Plus, this is relatively inexpensive, but it requires your time to find the product, to assemble it. To assemble the first 4 of these took me about 4 hours. Overall, I made 14 of these. One of them's in the back and it's not functional because somebody put 24-volt AC connection to something that was actually 24-volt DC, and it's hard. And it doesn't work anymore. So it said 24 volts on the nameplate. In my defense, anyway. So there's that basics that I think is really important about doing this way. Plus, you can set this up to your learning style. And that's what I've done here. I've set this up to my learning / teaching style. And in this case here, I've got one other thing I want to make a comment about. I have 4 different ways of making wire connections, or 3 different ways of making wire connections on this board. So I think that's another thing I want to bring into this.
Fantastic. I actually want to bounce back a question and put it out to everybody here. Does anybody have a controls textbook that they like? You've got the ATP ones, right, Justin? Okay. Hey, nothing wrong with that. They are great for the basics.
Basics, right, yeah.
Anybody else have a textbook that's not one of the 2 ATP books? Does anybody have a good online or curriculum resource or OER that they rely on a lot for controls?
If you do, you want to see links, document.
Manufacturer's data. I'm going to go back to that one because I said specifically on the devices, but when you get like the controllers, look up the documentation on those. A lot of times the manual for a given controller from a given company is usually around 100 pages. There is a lot of data there. A lot of it the early parts will push into the wiring type systems. In the middle, they tend to go a little bit on how that particular networking system works, whether it's IP or MSTP, which are the 2 predominant in the industry still. You can also look at some of what I call pre-configured controllers. So Ted has over there, he's got some white Honeywell controllers. Those are the old Stryker line. Those are a pre-configured controller. So it's already programmed, everything's ready to rock and roll. And the documentation on those goes into the common sequences of operations that that type of controller supports. And Honeywell is by no means the only one that does it. Ted has a Simply VAV controller there, or two of those in the back from a company called KMC. There's a company called Prolon that has a whole variety of pre-configured stuff, and apparently they've created one that's a programmable controller now, which is completely against what their whole system was about, but that's beside the point. But there are a lot of those pre-configured options. I have heard the term applied to those pre-configured options as controls for mechanical contractors or controls for electrical contractors, because they're really meant for people who can read a wiring diagram, install equipment, but that don't need to get into the programming aspects. Okay? They're canned sequencing, so it's a lot like your factory-controlled rooftop units. You get what you get. If you didn't want that, then you shouldn't have bought that kind of category. Those can also be really good resources. Something else I was going to mention for that. It'll come to me or it won't. Okay. Other questions before we get into the control boards themselves? Okay. So I'm going to lead off with a question. We do have some slides. A lot of what I'm going to do is on the whiteboard. I prefer that for interaction. Okay? My personal style. You just have to put up with it for a couple of days. I'm sorry. Okay? Question. What's this? Multimeter. We could get more specific about it, but I just want multimeter. Okay? What can I measure with this? Ohms, volts, amps. Okay? AC, DC. But we can get our 3 basic electrical measurements out of this, right? Okay? These controllers that you've got here, the inputs on those, they're a multimeter. They can measure 3 things and only 3 things, and not all of them can do it, right? Not all multimeters can measure amps, right? Not all multimeters can measure DC and AC. Anybody ever had somebody show up with one of those super cheap Cengage meters to your classes when you said you needed a meter? Anyway, sorry.
Those ones get free from Harvard Free?
That would be the one. I won't get into it. Anyway, so your controller, you can equate right to being a meter. Okay? So we're going to talk about the components on these boards. And we're going to talk about the components in a way that lets us equate them to topics on controls. Okay? I want to start off with the white thing on the left side in this picture. What's that? Say it again louder, Mike. Room sensor. Room sensor for what? Could be. So we know we should, in all of the things we talk about, we need to define a couple of pieces of information, right? Where? Not in this case. In this case, I'm talking about where does the sensor physically go? Room, on the wall. Maybe it's a duct sensor, and it needs to be stabbed into the ductwork. Maybe it's a pipe sensor, and it needs to be strapped onto a pipe or plugged into an immersion well. Okay, so we need to define where the sensor lives. Okay, every device we work with, we can define that way. Okay? Next question. What? What does it measure? Okay? In this case, it is a temperature sensor. We may have a range associated with it. So we may need to further define what? What is our range? Is it a room temperature sensor? We can expect it to measure between, 50 degrees, 40 degrees, 120 degrees, reliably, right? It may be able to measure outside of that, but is it the appropriate sensor for the job? Okay? Are you going to put a room temperature sensor in a sub-zero freezer? No, it doesn't make sense. Are you going to use it to measure the temperature of a hot water boiler? No, doesn't make sense. Renee, you had a question?
No, digital or analog.
Digital or analog? So along with our range, we've got some other questions. What type of signal? Okay? This is really important. And we also need to know not just what type of signal, but back to what Justin said a minute ago, which way does it go? Is it an input signal? Telling us something? Is it a sensor that measures real world data for us? Or is it something that's going to affect the real world? We have two categories of things for our devices that we wire to our controllers. We have sensors, measure the real world. Temperature, humidity, carbon dioxide, feedback. Anything else we measure? Flow, airflow, water flow. Static pressures, electrical flow, current, voltage. We've got, if there's something that we can measure, we've got a sensor associated with it, right? So we need to define on our signal in or out. What's an example of an out? What's going to affect our real world? Fan. Set point is an input back. That's our users providing information to us where they want it to be. Heating strips. Valves. Love valves. Dampers. Actuators that control those devices. Whether it's a proportional actuator, two-position actuator. We'll get into that here in a second. Okay? So we have to define in or out. Renee, what was it you said about the signal? Analog or digital. That's a horrible arrow. Oh, I forgot my disclaimer. It's been too long since I've done this. I use the whiteboard a lot, I already told you that, but I should caution you ahead of time. I can't draw, and I can't spell. Okay? So, if I write something up here that you have no idea what in the world I mean, ask. Back to those questions, right? What's that?
Check the menu.
Check the menu. Okay? So what do we mean when we say digital versus analog? Are we talking CDs versus records?
Modulate.
Analog is roaming or range on and off.
Analog has a range. Digital is just on and off. Right?
A yes or no.
A yes or a no. What's an example of digital that's super easy? Everybody relates to it. What's that?
Dirty filters.
Dirty filter, not what I was going for, but a good example.
On off.
On off of what?
Fan.
Fan, light switch. Of course, Ted's got to have a fancy system. Okay?
It's a Crestron.
Oh, he does have a fancy system. So, light switch, on and off. Everybody understands on and off of the lights. That is one of the best examples I've found of digital. Okay? Analog, on the other hand, per Arnaldo, is a range. What's an example of an analog signal? Sine wave. Yes, not something that we're usually going to get into for controls. 0 to 10 what? Volts. What else? Fahrenheit or Celsius? 4 to 20 milliamps. If we have a range to it, then it's analog. Okay? And we have analog and digital sensors for almost all of the things that we can measure. Okay? If we just need to turn something on and off in relation to a measurement, maybe digital is the way to go. Maybe it can be a completely standalone and we can stop there. But if we need to actually know that measurement for some reason, usually analog is what we go with, right? Okay. Digital comes mostly in two varieties for us. Anybody got any ideas? Not on the measurement itself, but when we're measuring digital information. Give me more than that, Renee. That's too deep.
Ranges of voltage and or current coming into or out of the device.
A fan status?
Fan status would be an example. I think Renee's onto it, but she's talking over my head on the electrical side.
0 and 1.
It's 0 and 1 binary.
What voltage or current you need to turn it on or off? TTL is going to be higher, CMOS is going to be lower.
Okay. I'm not communicating. So when we are when we are looking at digital information, there are typically two kinds of ratings that we get. Brad?
Normally open, one and closed.
Not what I was looking for, but another good piece of information. Trying to think, I'm missing it, so I'll give it to you. Dry contacts, no voltage present. They are just that switch on the wall. On, off. We have to provide them an electrical circuit, or electrical signal of some kind to run through it. Or wet contacts that provide us that electrical signal back. So we've got dry and wet. And as Brad told us, normally open or normally closed. Make sense? What's that?
Never did understand the term wet.
I don't know. Because it's the opposite of dry. I don't know. It's a good question. And
I'm with you on that, Brett.
to be perfectly honest, most things nowadays are dry. You don't run into a lot of wet contacts anymore, thankfully.
Would that wet be like the mercury floating in the bulb?
No, because that still was connected to a dry set of contacts.
Can you give an example of a wet contact?
The only place I'm used to seeing wet contacts anymore are pulsed signals. So when you get information from like a not smart electrical meter, they will can give you an output that's a pulsed output for every so many kilowatt hours that go by. And it will actually provide some voltage on that. Maybe? I don't know if EEVs are, they usually have their own controllers, so it doesn't, we don't tie those back to one of our controllers very often, too specialized. Okay? So, you can see how much I'm struggling to give you an example of a wet signal. It's just not very common anymore. Analog signals, on the other hand, much more defined set. Or less defined set? I don't know. Anyway. We've got 3 measurements, right? What are our 3 measurements for electrical? Volts, amps, ohms. Okay? So we can measure in volts, amps, and ohms. What are our ranges for volts? 0 to 10. 0 to 5. I would yell at myself for this. I insist on writing your units of measure. I'm being lazy today. Okay? Because 0 to 10 volts is way different than 0 to 10 amps. Okay? What else do we have besides 0 to 10, 0 to 5? That's PSI. We pretty much stop at 10 volts for the top end in controls. So if we're maxing out here, where else can we make a change? 2 to 10 volts, 1 to 5 volts, and sometimes, yes, we will do 5 to 10 volts. That's a weird one. That's somebody getting fancy with a signal. We don't see it very often anymore. Older systems, we did use that so that we could use one signal to control 2 different valves. Okay? These 2 to 10 volts, 1 to 5 volts are special. We'll get into why that is here in a second, but they're really, really useful. When we are measuring in volts with a controller, AC or DC? DC. Volts, for us, DC. We may switch AC to control things, but we always measure signals in volts DC. Okay? How about amps? What do we measure there? 4 to 20? Thank you. Milliamps. Not microamps, not amps, milliamps. 4 to 20. Okay? Now, this 4 volts is related, or 4 milliamps, excuse me. Again, AC or DC? DC. Always DC for our signals. Okay? And this applies to input signals and output signals. Okay? This 4 milliamps is related to this 2 volts, is related to this 1 volt. How?
The range where 2 volts related to 4 amps, which is the lowest.
They all represent
Correct.
It represents 0.
They represent 0. They're the bottom of our range.
And then, which is 4, which is the middle, the mid set, no?
Nope.
Oh, I'm sorry. Well, on the voltage part, 4 is the middle one, the middle range on the voltage.
For 1 to
2 to 10.
2 to 10?
4 is in the middle.
No.
50%.
B6 would be your middle, your 50%.
and then 7.
Will you restate that question again?
How is 4 milliamps versus 2 volts and 1 volt related?
Oh, that's the minimum that's required for something to change, like, for something to turn on anything.
Say that again louder, Mike.
It's the activation point at which that sensor is going to start reading.
Okay. So if we have a sensor that has a 2 to 10 volt range, what do we do when that sensor gives us 0 volts? It's non-functional. Your wiring is broken, the sensor is broken, somebody took an AV cart and took the thermostat right off the wall.
It's one of the questions, but is why do they make it 2 to 10, or can they just make it a 0 to 10? And that's what I tell students, what happens when the sensor doesn't work?
Absolutely right.
Do you know if it's working or not? An actuator? All right, okay, so that's why they made a range.
Control technicians love 0 to 10 volts because it's very directly equates to 0 to 100%. The math is easy. 2 to 10 volts, vastly superior signal because you know when the bloody thing is broken. Okay? So you can throw a flag in your system saying, hey, I'm broke, come fix me. Or the signal I'm giving you is not useful, don't use it. Go to a default value. Okay? There is a specific term for this called a floating zero. Our 2 volts in the 2 to 10, our 1 volt in the 1 to 5, and our 4 milliamps on 4 to 20. All the same term. Okay? We don't see very many controllers using 1 to 5 volts anymore. It's something that we used to see a lot in older DDC controllers because that's what they were capable of, because they grew out of the PLC industry. And PLCs, they don't use voltage signals. They use 4 to 20 milliamps. Okay? For 2 reasons. One, it's got that floating zero. Guaranteed, it's enforced. I have never seen a sensor that uses a 0 to 20 milliamp range. Your controllers will measure down to 0 milliamps, but nobody uses it. Okay? That's one of the advantages to the current-based signal. What's the other big advantage to 4 to 20 milliamps, that current-based signal?
Use them in a loop.
Use it in a loop? What do you mean by use it in a loop?
So the wiring is completely different from when you're using volts or wiring up for to take ohms or anything.
Not necessarily.
When it's wired in a loop.
In a parallel?
Like when I say in a loop, basically sometimes plus doesn't go to minus, and or like minus may go to another minus. It's a weird situation sometimes when you put things in the loop, wire them up differently. I forget exactly what it is.
So what Justin's talking about is with a 4 to 20 milliamp signal, we can use what is called a self-powered loop. So we can put voltage out to our sensor and get a signal back with just 2 wires. With our voltage-based sensors, we have to have 3 wires. We have to have power going to the device, we have to have a common or ground coming back, and we have to have a signal coming back or a signal going to. 4 to 20 milliamps, you can do it with 2 wires. I had forgotten about that one as a benefit. Thank you, Justin. Not what I was looking for, but a very good one. No, Brad, you don't get to answer this yet.
What was the name for loop?
Self-powered loop.
Wouldn't that give you
Like for troubleshooting, you can tell right away that something is down if it has below 4 or...
Yeah, that's our floating zero again. Yes. We could technically get that with our 2 volts though too. I want to take you back to basic electricity. Okay? Our circuits. Series versus parallel. What's the rule about voltage in a series circuit? It's additive. So ET equals E1 plus E2 for however many devices we have. Okay? What's our rule about current in a series circuit? IT equals I1 equals I2. Okay? What does it matter? What's the one assumption that we always make when we are doing these calculations as examples, teaching people the electrical math?
The voltage is always the same?
The voltage is always assumed the same.
Nah. Say it again louder, Renee.
You're counting out the resistance of the wire. You're using theoretical.
We're assuming our wire is a perfect conductor with 0 resistance. Okay? If I have a sensor that's here physically and a controller that's here physically, what's the resistance of the wire between these two? Let's say 18 gauge wire. Really close to nothing. Effectively, for our ability to measure, it doesn't matter. We can assume it's 0. Now, if I have a sensor here and I have a controller that it's connected to 1,000 feet away, now that resistance starts to become significant, right? And we get a phenomena called, say it again louder, Brad. Voltage drop. Floating zero. Current is constant. We could have a sensor that's running a current signal a mile away. We might have to turn up the voltage to make sure that the sensor still operates, but that control signal, that measurement signal, it doesn't care. It could go around the earth in theory. Practicality, it doesn't actually work that way, but that's beside the point. The theory states, and the practice in applicable situations, it works. I ran into a sensor in an oil refinery that the wiring literally ran 3.5 miles. Don't ask why. I had it explained to me and I still don't agree with the explanation, but beside the point.
That's the way George did it 20 years ago?
Not quite, but almost. But it was a 4 to 20 milliamp signal, and it ran through that 3.5 miles of wire just fine. So no voltage drop, no less signal degradation because of distance of wire. Can still mess with it plenty of other ways. Okay?
When you said that we can increase the voltage, I thought we are limited to how much volt we can use with this sensor. We cannot just increase the voltage.
Yes. So for example, that particular sensor was a 24 volt DC sensor at the sensor end. To get the voltage there to operate the sensor, because again, they were running it from the other, literally the other end of the plant. they actually had the voltage turned up on the DC power supply to about 78 volts. It won't, because we have so much resistance between there that by the time it got to the sensor, it was actually measuring about 22. They had to stop at 78 because that's all that power supply would put out before it started blowing fuses. Yeah. So, really weird scenario. You will never have anybody who has that. Well, I won't say never, because it happened at least once.
Do you have any issues with latency when you deal with something like that?
Not effectively. So that's a good question, though. One thing to keep in mind, and it's a really good difference between lighting controls and HVAC controls. What do you expect to happen when you turn that switch on? The lights to turn on, right? At home, when you turn that switch on, think about incandescent bulbs. How long did it take for the light to turn on? Less than a blink of an eye? Anybody have some of the newer LEDs and you hit the switch and it takes about a second and a half for it to turn on? It's a noticeable difference, right? And I don't know about you, I notice it every time. With lighting control systems in commercial buildings, it's the same thing. If somebody hits the switch and they don't see a nearly instant reaction, they think something's wrong. Okay? Climate control systems, we hit a switch, sometimes we go get a cup of coffee and come back because that's the kind of delay we're waiting on. So for us in climate controls, latency is, I won't say never an issue, because it definitely is, but we're so used to all of our processes taking time anyway that we really don't notice it as often. Jose.
So, transfer, is it temperature? You have a temperature sensor, and it does has a there's a transfer function to say on those amps, milliamps. Will it affect on the actual damper function, in the sense that it will take a while to it reacts to what it in need of a temperature or cooling per se, or humidity? There is a time sequence that it might affect, right?
Yes. So so what Jose is asking, if I understand right, is when you get a signal from a sensor, there is a quantity of time that usually takes place between receiving that signal and actually beginning to act on it. Yes. And that is distinctly variable depending on what we're controlling, the level of importance of it, the age of the system. And most of the time, we don't want a lot of our stuff to control fast, not when it's analog signal based. If we want something to control fast, we usually go digital, right? Okay.
In general, in HVAC, we do everything slow.
Yeah. Yeah. Time delays are your friend. Slow reactions are your friend, because let's face it, how long does it take to heat up or cool down this room 1 degree? Ought to take a couple of minutes, right? Because if we do it quickly, we have a lot of consequences we have to deal with, right? Usually in the form of complaints of the occupants. It's too loud because there's too much air. There's cold air blowing down the back of my neck. There's hot air blowing down the back of my neck, right? Overshoot. We go too far too fast. Humidity. Okay? So it's one of those complex things. Most of the time for us, slow and steady is good. Fast changes, scary. Bad news. Okay? Not always. There are things that we need to have happen fast. Safety devices in particular. Okay?
Which way the voltage goes when the temperature increases? Right? Would it increase or decrease?
And that comes back to our range. And it really depends on the sensor. We'll get into that here in a minute when we talk about our devices, because I went back into my default lecture here instead of what I'd actually planned to do here. So we'll finish out our last signal here and then get back to the devices, because I wanted to use the devices to illustrate these as we go instead of downloading all of it at once, which isn't as effective. You all can keep up with me. Students sometimes can, sometimes can't. Last reading, or measurement. Ohms. What do we use resistive measurements for? Temperature. Not exclusively, but so close that it doesn't matter. Okay, so if we're measuring in ohms, we almost always mean temperature. What range?
You mean the ohms or the temperature?
Yes.
The ohms.
It depends on the application.
Yeah, it depends.
It depends. Great answer. I love that. You could be an engineer. Sorry, I throw mechanical engineers under the bus all the time, and it really is good-natured for the most part.
Don't get us wrong.
So our answer is it depends. And you notice when you asked whether I was talking about the resistance measurement or the temperature measurement, I said yes. One of the things you will find from me as we go through this, you may ask a question and I do the best to give you a non-answer so that you can think about it and give me an answer. There will be times when you will ask a question, especially when we're doing a lab, and I'm going to say, you know what? That's a great question. And then I'm going to walk away. Which, for me, is a teaching tool that means I think you can learn a lot more by finding that answer yourself. I think you have the tools to find that answer versus me just giving you the answer. A little bit of frustration goes a long way in teaching. I don't know about you, but anytime I have had to fight to figure something out, I learn way more than when it is easy and just works. That's been my personal experience. So, with our temperatures, we do need to define what we've got for a range. And it may be a closed range, or it may be an open range. You know, this sensor, our room temperature, for example, they usually prefer something between freezing and 110, 120 degrees. Outside of that range, they start losing accuracy and or precision. Okay? What's the difference between accuracy and precision?
Accuracy, you hit the target. Precision is you're on the spot on the target. Think about it. I could hit the wall, that's accurate. That's what I was aiming at. But if I want to hit the IT, that's precision. Repeatedly.
I disagree because I think you're saying the same thing twice. But I like the target analysis. Ted has two whiteboards, so I don't have to erase the things I care about. Think about your standard archery bullseye, darts bullseye, whatever your favorite is. If I can throw a dart and hit the center of that target, it is, Mike? No, accurate. If I can do that once it's accurate.
You do it 10 times.
If I can do it 10 times on the target, it's both precise and accurate. If I can hit this spot consistently with a tight grouping, that's precision. Hitting it multiple times in the same area. For most of our sensors, we need to be accurate or precise?
You can tune in the accuracy, you can't tune in the precision.
I disagree. You can tune in both of them in. I think I heard the answer I wanted to hear from one person. Both. We need to be both. Anytime we are taking multiple measurements, we need them to be close relatively. Okay? If we're not having something that causes the difference between them, if we have 4 temperature sensors here on the wall right next to each other, they should all be reading about the same number, right? We run into issues with this when we have sequences of sensors throughout a system. The difference in temperature between the air coming into the fan versus going out of the fan versus where it crosses the coils. If we have multiple sensors there, if we're not doing anything to affect the temperature between them, they should be very similar, right? Otherwise, it's a sign of a problem. But we also need them to be accurate. If it says 72 degrees on all 4 sensors, but really the temperature in this room is 68, is that good? No. Accuracy and precision, 2 different things, but they are both important. Accuracy is more important when you have a lone sensor. Precision for multiple sensors. Make sense? You're looking at me, Renee.
Yeah, precision aspect is really important when you're looking at trying to measure your percent outside air using temperatures.
Yes. A lot of our calculations rely on the precision more than the accuracy, as weird as that seems.
It's all relevant.
Yeah. What do you think, Renee? I can see the gears turning in other people's heads. I'm just picking on Renee.
I'm going to go down a rabbit hole. But if you're looking at multiple sensors and you're looking at precision, yes, you can tune it in. Or you can get a new sensor put in the place of another one.
Mm-hmm. Both correct.
Always tune in your accuracy, but you cannot change the electronics within that sensor easily unless it's a
adjustable, tunable sensor, correct.
So when you're looking at precision or accuracy for one sensor, not multiple,
Mm-hmm.
why would you say that accuracy is more important than precision?
Because precision relies on multiple measurements.
Okay.
If you're talking, maybe you mean precision over time in this situation?
Yes.
In that situation, it is as important as accuracy.
Okay.
So if you have a sensor that goes wonky, technical term there, right? Wonky? You know, every 10 minutes, that's not good, right? That's a sign of a problem. Normally in our industry, it's not because of an internal thing to the sensor, it's because of an external influence, and you should pay attention to that whoopsie and figure out why it's happening. Do we have a compressor that's cycling on and causing a low voltage situation that's causing our sensor to dip out for a second? Something like that. Or, you know, is the room temperature sensor great until 3 o'clock in the afternoon, but between 3 and 5, its readings are way too high? solar gain. Somebody put the sensor in a spot where the sun beats right on it. Or it's great from, 5 o'clock at night to 7 in the morning. But during the day, it's not a good reading. External influence of some kind. Great questions. Any other questions so far? Steve.
Using different sensors like 10K versus the copper that are 0 to 1,000, why would you use different ones for different situations other than precision or accuracy? No, but what is the situation? Because most everything you run into is 10K, but then all of a sudden you see these.
So, great questions. So Steve's starting to ask the question on the other side. We have temperature. The other side is our resistance. And the vast majority of sensors that we use in building automation systems is what type of temperature sensor? More generically, what's the name of that type of sensor? Thermistor. Okay, what's the definition of a thermistor?
It's a thermal resistor.
It's a thermal resistor, or, to use more words, a resistor
That changes value based on thermal.
there we go, that changes its resistance based on the temperature it's exposed to. And what is the most common base resistance that we use for our thermistors in our BAS industry? I'm being 10K. 10K ohms. 10K ohms. 10,000 ohms. What does that 10,000 ohms mean? And almost all of our thermistors we define to start with a resistance value.
10,000 ohms at 77 degrees.
At 77 degrees. It's our standard calibration point. So if we say 10K, we're just leaving off the at 77 degrees Fahrenheit. I'm out of space. I'm going to have to erase things here in a second.
We can erase this stuff over here.
Go for it, Tim. Okay. I will warn you before I erase things, if you want to take pictures of what I've written on the board, you're very welcome to do so. If you need me to move out of the way so my big head gets out of the way, that's fine. Okay. So, at 77 degrees Fahrenheit, why 77 degrees Fahrenheit?
25 Celsius.
Say it again louder.
25 Celsius.
It's 25 degrees Celsius. It's our standard of calibration internationally, is 25 degrees Celsius. It just happens to convert to 77 degrees. You are the only person I have ever had in the class who knew that. Thank you. Okay? So, we will have a resistance value, 10K for our example. See, you guys thought I was going to favor them the whole time, didn't you? So we have 10,000 ohms at 77 degrees Fahrenheit. Right? Is that all the information we need about this thermistor?
No. What type?
What do you mean by what type?
That, yeah, well, there's different.
There are different materials that consist. 10K is one of the weirdest, most annoying sensors. Because a lot of our sensors just have a resistance value. 20K sensors, for example. 20K thermistor. There is only one type of 20K thermistor, so when we're defining it, we can stop right there. It's still at 77 degrees. Brad, there was something you said about thermistors. They are non-linear. Okay? We love linear things, right? Our 0 to 10 volt signal, 0 value, full value, straight line between them. They're great. Thermistors, nah. They can go any which way. Positive temperature coefficient, negative temperature coefficient, just tells you which direction the resistance goes to increasing temperatures. So, with any thermistor, there's a chart. Right? Because it wasn't complicated enough. So there's charts to look these up, which can be a really great exercise that Brad's going to tell us about.
On
Wednesday. Sorry, days of the week. Okay? But there's an exercise you can do with these. 10Ks are one of the annoying ones. There are two annoying ones. But 10K thermistors can come in a type 1, a type 2, or a type 3. And it just matters which chart you look it up on. Type 1, very rarely used. Type 2 and type 3, very frequently, and sometimes you flip the coin. Sometimes you win, sometimes you lose. Or you learn to test the sensors and figure it out. Okay? But back to Steve's question, why? Why don't we just use all, 10K type 2 sensors? Why doesn't everybody use that?
Because on the range of the temperature per se,
Application, temperature range. Is it good for room temperature versus hot water temperature, for example? Not significantly different. Good thought, though. Material being used will affect which type of sensor or resistance range we get. It may affect the overall lifespan of the sensor, good quality materials versus garbage.
Depend on the controller you're using. The controller you're using, what it's set up.
Anybody know who uses 20K thermistors? Honeywell.
Actually, I bought one on eBay for like $20 from the 1990s.
Yeah.
Because in new it's like $680. They don't make it anymore.
That sounds right. And that gets exactly where I'm trying to go. Why doesn't everybody use the same one? What's that?
Manufacturer preference.
Manufacturer preference, leaning towards proprietary. If Honeywell only uses 20K thermistors, how much of a pain in the keister is it going to be to come in and change out to a different controls manufacturer? Is it going to be easier or harder? Harder. So that's why. Everybody makes all of these sensors, and some control systems can play with multiple types of sensors. Contemporary Controls being a great example of that. They don't care. Honeywell, if you've got a Striker controller or their Spider controller, which is just the programmable version, they have to have a 20K sensor. So if I've got a Johnson Controls thermostat on the wall behind Kim, that's a 1,000 ohm platinum type thermistor. Can I use it for Honeywell? No, I have to go and buy Honeywell's 20K thermistor, or from a third-party manufacturer like ACI or BAPI or the 20 other manufacturers that make the bloody thing. Helpful? No. The way it is? Yes. Sorry. It's money. Absolutely. It's the same reason why it used to be that every controls company had their own proprietary communication protocol. So that when you installed Johnson Controls in your building, and I'm not picking on Johnson here, everybody did it. You had to keep putting in more Johnson Controls because otherwise it wouldn't talk to the existing system unless you wanted to spend a lot of money to make it work. Again, sucks, but it was the way it was. Now, questions on that? Okay. 10K and 20K are not the only type of thermistors. What other types do we have? You heard me say one of them. 1K. And this is another one where we have to define something. You're supposed to give me the 1K platinum. Because we couldn't just keep using type, could we? Platinum is one option for a 1K. Balco is another. BLCO. Nickel. I'm not familiar with that one.
Yeah, I use it when I use EZI
Oh, 10K Invensis. So Invensis was a controls manufacturer. They became TAC, which became Schneider Electric Controls Division. Okay? Again, it's not easy. With our 10K, we can also have with an 11K shunt. Which means it has a 11,000 ohm resistor in parallel with the sensing bulb. No, I don't know why they did it. Maybe we can ask George that tomorrow. Okay. 1K. These are the three I'm familiar with. There might be others out there. I fully acknowledge that. I don't know everything. Any other temperature range or resistance calibration numbers we know? 3.5K. That one's just one of those flat ones, isn't it? There's not multiple versions. Okay. 100K. Not very common anymore. And this one, I believe, also comes in a platinum and Balco version. Okay. Now that we've gone through all of this, I'm going to tell you that knowing all of these varieties is completely unimportant. Now that we spent 10 minutes going over all of them. What is important? The conversion, knowing that there are charts associated with each of these. What else? We'll go manufacturer specific because mostly, not exclusively, but mostly the manufacturers are going to stick with one standard or favor one standard.
Yeah, but if you have the same 10K, the same, it doesn't, I mean, the controller wouldn't know. Besides the ohm and if it's going up or down, that's all you need.
Well,
If it's the right
type.
chart, the right type.
Yeah, exactly. It doesn't matter whether you have if it's a 10K type 2, it doesn't matter if it's a wall sensor or a duct sensor or an immersion sensor for water. The controller doesn't care at that point. It measures a resistance.
Yeah, I don't really know what type 2 means.
It literally means
Is
it.
it go down when it gets hotter or does it
Almost.
NTC or BTC?
Almost all of our temperature sensors or thermistors that we use are NTC, negative temperature coefficient. So as our temperature goes up, our resistance goes down. Ted. Oh, I'm being too long with this. Got it. Thank you. Okay. So the fact that it's usually manufacturer specific is important. The existence of the reference charts is important. Knowing that multiple types exist, important so we can inform our students. Knowing all of the individual ones, no. Okay. All right, questions on that?
How do you know which one to use? I know you say it's manufacturer specific. Is it just like how would one the sensor not working? How would I know which one I need to use to replace it?
Great question. So let's look at the temperature sensor on our board. So that white box. What part number is it?
And these covers they just move up and flip off. Really easy to take off.
REV3, that's the revision of that electronics board.
So sensor 2,
S1.
there's the S1, R1,
All right. So this is a prank I love to play on my students. ACI puts that piece of information on the back of the plastic board. So I'm not going to make you look it up. If you look at your parts sheet, it will tell you what the piece is.
I was going to ask, in controls, do you typically have a cut sheet or drawings?
Yes.
And the reason I ask is, any electrical world, and in troubleshooting, you don't want to make the assumption that what is there was correct in the first place.
Absolutely true.
So, like I suggest going to drawings and finding out what was stacked.
Yes.
And moving it from that point as opposed to just what's there.
Yes. So the part numbers should show up on the drawing, and the there could be a parts list associated with it, all kinds of base references. But you should always field verify. Trust, but verify.
Right. Unless you've been in a place a long time and you know all of the ins and outs.
Absolutely right.
Assume that just because it's there, that's what's supposed to be.
Correct. Absolutely right. Absolutely right. And you can play pranks on your students that way. And when I say play pranks on your students, I'm meaning creating a learning opportunity. I think Brian used to call it a learning trap, if I remember right. Okay? So what is the part number for our temperature sensor according to your parts list? So it's a big, long parts number, right? Am I okay to erase over here? I should ask Ted to do that for me.
Sorry.
Nope.
I'm working on something else.
That's because you're awesome, Ted.
We got another burnt out fan, probably from the last workshop.
Ah, well. So we have an A/1K.
1K.
Dash W, dash R2, then you have a 1K, RTD.
So this is actually on a separate line, right? Oh, same line. Okay.
It's on separate.
It's on a separate one on the packaging. Okay? So, part numbers. Do you teach your students how to read part numbers? Why?
Make sure you get the correct part.
Because they're going to have to do it out in the field, right?
Well, not only that, but in this case, the R2 could be replaced with an R easily because it's just a color code. So if you had the wrong color code, it would still work for you.
So, I don't teach people to read part numbers because part numbers are manufacturer specific. And if you went with a BAPI brand sensor, it would be a different part number. I teach students to go and research this and find what it is. Okay? I'm familiar with this brand, which is lucky for me because it's Ted's lab and his sensors. Okay? This A here at the beginning is an ACI brand sensor. They're based here out of Wisconsin. I can't imagine why Ted gets from there. They're actually a really affordable brand while still maintaining quality too. But, so, if you Google or if you search this part number, you will get information about it. Okay, you will find out that this 1K here is our type of thermistor. Okay? In this case, it is a 1K nickel.
I think it's platinum, but I don't know for sure.
We looked it up
We did. That's why I'm
the other day.
So I was thinking it.
Okay, we'll pretend it's a platinum.
Oh, it is a platinum.
Okay? The 2W? 2-wire. In this case. They do have 3-wire sensors. R2? The style of that box. That's all that is. So they've got an R1 that's a little blockier design. Nobody cares. Architects care. The 1K RTD also tells us back that we're 1,000 ohms. Okay? Now I do want to point out this particular sensor is an RTD, which is slightly different than a thermistor. Because why make it easy? Usually when we use an RTD, which stands for resistive temperature device, we actually have, instead of wiring it directly to a controller, we have a translator that goes between and turns that signal linear. So we get that nice straight line. Okay? Doesn't mean we can't wire it directly to a controller, because guess what? We're going to. And later today, I'm going to make you look up the chart and cry. I mean, look up the chart and program it in. Okay? So, RTD. There's another type of temperature sensor, right? Just so that we make sure we mention it. Thermocouples. I will tell you that almost exclusively we do not use thermocouples in controls. I think I've used one in 21 years. What's that? No, it was running a low current relay. It was weird. So a thermocouple, what is the difference between a thermistor and a thermocouple? A thermocouple generates current. A thermocouple takes two different metals, sandwiches them together, and as we apply heat, we get different quantities of current from it. We typically measure it in milliamps or microamps. They are very stable long term, and if you get the right ones, you can get decent accuracy. We do use them in boilers, not so much anymore. The big place we still use them is water heaters. So, and some of our flame sensors in furnaces still use thermocouples as well. Same idea.
What's the benefit from using one versus the other? Why thermocouple, why thermistor?
Thermocouples are hard for us to read. Our controller, because their resistance range, or I'm sorry, their current range is either not very big for the temperatures that they read, so they're good at measuring big changes like no flame versus, hey, I'm in a hot flame, versus our thermistors, which are good at reading those small value changes. Also, thermistors are cheaper, which really drives so much in our industry that it's disgusting. Thermistors, by the way, the cost to actually buy a thermistor, just the sensor itself, which you can see on these boards, that little white dot in the bottom left corner, that's the actual thermistor. The rest of it is just the dressing for it and how we connect to it. That thermistor itself costs cents. And in the quantities that companies that make this stuff buy in, it doesn't even cost a cent per thermostat. By a factor of 1, tenths of a cent. So, okay, I've killed temperature sensors too much now. Any questions on that? Okay, so again, part numbers we all agree are important, mostly because we need to be able to research them. Can I replace this 1K platinum sensor from ACI with a 1K platinum sensor from Honeywell?
If it's too high, yeah.
Yeah.
Does a platinum mean the difference is the same as the temperature changes? The temperature?
Oh, a more linear response?
Yeah, like the same linear?
I don't know.
If it is, then yes, you can replace it. If it's not, then not.
Well, remember, this, when we say 1K platinum, we're applying a standard. So 1K platinum by ACI versus BAPI versus Honeywell versus JCI should all be on that same standard. They're agreeing that, hey, we're adhering to this standard.
Then it should be fine. Yeah.
Then it should be fine. Okay? Could we replace this 1K platinum with a 10K type 2? Not as a direct replacement. We might be able to do it, but there's a lot more work involved. Brad?
Depends on what controller you got.
It depends on what controller. A JCI controller, no. Contemporary controls or an Easy-IO controller, yeah. We could do that. But we would also have to get into the programming and change it accordingly. It's not just a take this one off the wall and put the new one on.
You'd have to define your new sensor.
Correct. Laura, did that successfully answer your question? It took me 10 minutes to do it, but we got there. Okay. So that, how many wires, or do we need to measure a temperature? Two, right? Almost all of our sensors are going to need at least 2 wires, right? We don't do anything funky like we do with furnaces and use the ground connection to complete our connection. We're not automobiles here, though there are some manufacturers that do that and get electrical inspectors really excited. Ask me a story over lunch. Okay? So we need 2 wires. So when we wire up this sensor, we are going to wire from our sensor to our input UI1. Our input UI1 has 2 terminals. What are they labeled? A and C. What is, Laura?
What does that mean?
Great question. That was what I was going to ask. What does it mean?
Where's the manual?
What's that?
Where's the manual?
Where's the manual? Great answer. I like that. C is common. Okay? A?
How do you define universal input? Could be power.
Power, signal, whatever. Different manufacturers use a different term for this. They can at least agree on common, so yay. We'll take that as a win.
There's other ones that say A and B. What does B mean?
So is that a UI? No. We'll get there. Okay? So our signal goes into A. When measuring resistance, is resistance polarity sensitive? Nope. So does it matter which wire we put on which? Nope. Not unless we have a grounded sensor, in which case it does matter, but I've never run into one that was grounded intentionally.
Well, it matters if you got a boss you're working for that really likes his color codes the same.
Color codes, that's a different story. Okay? Now, I get myself into trouble with this, especially when talking with HVAC and electrical. So, if we are dealing with a 120 volt AC electrical circuit, what's our color code? Black, white, and green, or bare copper. What's the black wire? Hot. What's the white wire? It's the grounded conductor. Sorry, I had to be a smartass. I'm practiced. Okay? And ground, of course, we know. Low voltage controls. In BAS, black is common. Okay? So if you have color-coded wire, common gets the black insulated conductor. You go talk to a residential guy in HVAC, you may find out that they use blue as common. That's less standardized because
Most community manufacturers have gotten away from the red and black and have gone yellow and blue, which is beyond.
yeah.
For the 24 volt AC.
Yeah. So part of why I use black, and that's the industry standard, is because that's how I was taught. We inherit that from instrumentation and PLCs because that's what they do. And you know why they do it? Because in a 2-conductor cable, which means we've got 2 insulated wires in an outer jacket, that's a cable, there was always a black insulated wire. The other one might be white, might be red. Those were the old common colors. Some of the new ones go different colors. But there was always black. So black became common. logical. Okay? And it throws electricians totally for a loop. They'll start looking at it and going, why is hot running to everything? That shouldn't be right. It's a lot of fun. Okay? But, back to your comment, read the drawing. Because just because it's an industry standard doesn't mean the person who was here before followed the industry standard, followed the drawing, doesn't mean they didn't do it the wrong way, and that's why the thing isn't working right. Again, for temperature, when we're measuring resistance, we don't care. Okay? I ran way over, didn't I? Okay. Questions on temperatures? Central.
I got a question, because right now sitting there talking, so you have a plus and minus here, so I assume that plus would be your signal, and the minus would be your common?
Correct.
Am I understanding that correctly?
Yes, you do. Minus for us, anytime we have plus, minus, anything like that, minus is our common.
Is that because it's a RTD? Because there's many chemistries that are non-binary, so it won't matter?
So I know for a fact ACI labels all of them plus and minus. Whether it's an RTD or a 10K or a 20K, that's just their standard.
But is it still non-binary, or is it?
You're saying non-binary, you mean polarity insensitive?
Yes.
Yes, it is still polarity insensitive.
So realistically, you could wire it either way.
Yeah, this is literally something that it's hard to wire wrong. Not going to say it's impossible. I've definitely seen people do it. Don't put 24 volts to your temperature sensors. I ruined Renee's lunch by saying she couldn't do that. Yes, you absolutely will. I had an apprentice do it with an entire floor's worth of smart thermostats at $120 a pop, and this was 15 years ago. I was the programmer, not the project manager, so I only had to warn him to duck when the project manager came on the floor, instead of having to yell at him and explain it to the owner. But it happens. All right. Other questions or comments?
So this is sometimes you have a sensor, for example, if you have a current sensor as you want to use it with GS8000, for example, one of the controls, you know that GS8000 would take 10K. Right?
Yep.
So there is a way where you solve resistance. So I'm trying to figure out there is a way where you can use a sensor, current sensor, and you do some kind of circuit to change it from current sensor to resistance.
So it's not a circuit that you would use in that case. There's a programming object that we would use to do that. And there are a couple of options there. And we will get into that in the afternoon if I can shut up long enough to get there. But yes. Yeah. I will tell you that on an output side, so most of the time resistance, like I said, 99% of the time or greater, you're dealing with temperature, right? There is still that 1% hanging. For anybody who's familiar with rooftop units or makeup air units, anybody remember the old Honeywell Modutrol actuators? They are a metal box about the size of a lunchbox. They weigh about 30 pounds, and they are a absolutely long-lasting, brilliant actuator. But they use a resistive control signal, which is completely a proprietary idea and is very hard to replace with a modern actuator. So you have to go to Honeywell and spend the $600 to $1,200 for the replacement. Proprietary technology, gotta love it. So there are examples where we do use resistive for an output, but that is literally the only example I can think of in climate controls. Some lighting control systems use it.
KMC actuators used to have a variable resistor that they used for feedback built into them.
Okay.
The little blue ones.
Yep, I know which one you mean. I forgot about those. Other thoughts, questions, resistive control signals? I promise we'll actually get into something to do with hands here after lunch. Ted wants to say something. He's
Yeah. Who has a cane?
No, that's reasonable.
So, we are going to go to lunch, but you have a working lunch today. And thanks, Robert.
My fault.
So, what we're going to do is, over lunch, everybody, you're going to look at your boards. He's done a pretty thorough job of this 24-volt thing and not wiring up to the wrong things, blow it up. Hisham already brought me one a fan that was not functional, probably because somebody connected to 24 volts AC. There's one back by Rob on the bench back there. There's one back there by Rob that I actually connected to 24 volt AC last week by accident, and it doesn't work anymore. So we have to be careful with our wiring. We're going to start doing a little bit of pre-work to Wednesday's class on troubleshooting. I want everybody to look at their board, trace your 24 volt AC coming off the transformer, and make sure that all the wires going, it should be follow all the red. All those red wires are going to only items that require 24 volts. Your items that require 24 volts AC are going to be your controller, your pressure sensor, which you're going to have to wire up, by the way. You're going to run 24 volts to the two actuators. So red to red on these things. And I think that's it. The IDEC, probably, yeah. But we're not at the IDEC yet, so we'll get to that. So make sure your red wire is going to the correct items. And you'll notice that there's a 5 connector waggle. These little things are called waggles. They're great, but they're really messy. Look at the wiring. I want, at least that's my feeling. You give me feedback later on. But the waggle is doing red from the transformer. 2 of them go into the input or the outputs for the actuators. So the controller is going to decide whether that actuator gets power or not. And or in this case, everybody should be wired to the LEDs. These are 24 volt AC LED lights. I think you can probably do AC/DC on these. It doesn't matter. I'm not 100% positive, but I think it should. And the controller. If you're 100% confident that yours is not wired to the wrong components, you go ahead and power her up and check it out, make sure nothing fries. But I need you to check that out just to make sure, and this is stuff you want to do with your students too, that everything is good. For your students, I would suggest that you check them before you let them power it up. That's always a very difficult thing.
Yeah.
So.
One of our longtime members, Bob Clark, has a saying: there is nothing that is student-proof, only student-resistant. So double check their work before you let them plug things in. Otherwise, they will find out how to blow things up on you.
I've actually gotten to the point where I print off my roster
to like check their name on, because I've been a couple of students and then until the smoke came out.
Yeah. That smoke's hard to get back in.
It really is.
So, one more thing. We were going to have somebody speak over lunch a little bit. I have former students that were going to come in. I invited 3 students, but, you know, they're out there working, and for some reason, their bosses said, no, you can't go that day now. So, they weren't able to come in. We're not going to have students speak. We replaced one with Laura on Wednesday, but that's it. So, we got an hour for lunch, and so we're going to take that hour for lunch right now. Did you guys have something?
No, the lunch is ready.
All right.
So if you've got questions, ask them. If you're unsure of what you need to do over lunch besides eat lunch, ask.
We'll be roaming around.
Yeah, go for a multimeter if you need one.
Yeah.
They're in the toolbox.
Oh, okay.